Good morning, Dr. Rajshree.
Let us start. Before we start, formally, let us informally meet the 3-4 faces which are very common to us. Let me welcome Dr. Abhijit Majumdar. Let me welcome Dr. Tasneem Sheikh. Madam, you are here. Thank you very much for this. And Mr. Gohain. DJ kidhar hai? Ha, Divya. So it was a nice meet. Dr. Abhijit is also there. Divya is also there. We are all definitely there. That's how it is.
Shall I start, sir?
We can wait for a few seconds. I'm just waiting for, I'm expecting Naveen Agarwal to join during the inaugural session from ATE.
Yes.
And let's see if he comes. Otherwise, 10:30 we will start. And Mr. Kanoi from TechFab India is expected to join, but he is yet to join. Abhijit is already there. Yeah. Ranjit, you can start with, yeah, please.
Yes, sir. A very good morning to all. I, Ranjitan Rukmani, Assistant Professor, Center for Textile Functions, feel privileged to host the inaugural ceremony of 6th Management Development Program on Future of Synthetic Fibers in India, organized by SVKM, NMIMS, and PSTME, Center for Textile Functions. We are honored to have with us Chairman of the program, respected Dr. Akshay Malhotra, Director, NMIMS Shirpur, respected Dr. Arup Rakshit, Associate Dean, Center for Textile Functions, Shirpur. The eminent expert speaker from leading textile industries, Mr. Sandeep Acharya, International Consultant, PCF, Uzbekistan, Mr. Biplab Chakrabarty, Vice President, Fibre Production, Rajshree Polyfill, Bharuch, Gujarat, Mr. Sudipto Mandal, Assistant Manager, Sales and Marketing, Oerlikon India Private Limited, Mumbai. Mr. Manish Barot, Head Technical Sales and Business Development, TechFab India Industries Limited, Mumbai. And Mr. Sandeep Nevatia, General Manager Marketing, Polygenta Technologies Ltd, Nashik. Special dignity of our today's MDP are Dr. Tasneem Sheikh, Associate Professor, Department of Textile Engineering, University Baroda, Mr. Naveen Agrawal, Vice President, ATE Enterprises Private Limited, Business Head, Fabric Forming Division, Textile Engineering Group, Mumbai. And we have with us distinguished guest, Mr. Anant Kanoi, Managing Director, TechFab India Private Limited, Mumbai, and Mr. DJ Goen, Director and Publisher of Textile Excellence. On behalf of Center for Textile Functions, I extend heartiest welcome to all the dignitaries, participants, colleagues, and my dear student in this management development program. As we know, synthetic fibers play a key role in day-to-day human life. Along with the apparel, synthetic fibers are used in numerous industrial, outdoor, indoor, and commercial applications. Last few decades, we have seen significant growth in the consumption of synthetic fibers globally. Synthetic fibers do not wrinkle easily and possess good elastic properties which make them comfortable to wear, and technical properties make them to use in wide industrial applications. The expert sessions are scheduled from 11 a.m. to 12:30 p.m. and 1:30 p.m. to 3:45 p.m., followed by concluding session, participant feedback, and vote of thanks. So I request all of you to be with us. Now, I would like to invite our beloved Associate Dean, Sir, Arup Rakshit, Sir, for inaugural address.
Very good morning to all of you. It's a great day for us, as you have already heard about the introductory address of Professor Ranjit Rukmani. This is the 6th Management Development Program from CTF Shirpur NMIMS campus. The earlier programs are also available on our YouTube channel. The students, the company members, and all other participants are also requested to refer those links to understand about the earlier programs. The purpose of the program is to educate the technical people in the industry by and large, plus the students, researchers, and it's a platform to meet all the stakeholders of textile industry in the entire value chain. Right from the beginning, we have addressed the topics like weaving, spinning, entrepreneurship development, and similar ESG in textile processing, and similar such topics. The sixth one is the synthetic fiber, which is one of the pivotal entity in the entire textile value chain. We will be listening to the specialty applications of the fibers, and including recycling, which is one of the most important and much talked about issue. In fact, when textile processing program was there in the month of January, the ESG or the sustainability of the textile industry in all value chain had been discussed in detail. So similarly, the recycling has also given an emphasis in this particular program. Besides the fibers like BCF, tyre cord, little bit, those were the specialty in applications, which leads us to more talk about technical textiles, which is a very important area for everybody to understand, even if this particular process or the subject is there in the syllabus as well as in the industry for nearly 20 years now. But I still believe that there is a scope to understand more about the applications and even the development of entrepreneurship. I am extremely pleased and honored to get a couple of persons here. And first, let me address Dr. Tasneem Sheikh, Madam from MS University, Baroda, who is our BOS member, Board of Studies member. I could just see Sudipto on the line. Let me welcome Sudipto. Thank you very much to be here. MS University Baroda is actually has a lot of support to our department as well. Besides being Dr. Tasneem as a member of BOS, who has contributed a lot about the framing a new syllabus. The students completing diploma for our institute also get admission, lateral admission in MS University's BTech program. It's one of the very important aspect that there are two institutions where the students are normally getting admission, lateral admission, besides our own UG program. One is MS University and the other is SVIT Indore. So these are the possibilities. And the second person I would like to address, Dr. Abhijit Majumdar, who is also our BOS member and a pivotal person, I think the key person to undertake the most important survey program sponsored by the ministry for technical textiles in India. Abhijit, thank you so much for this particular contribution to, let's see if you are there, kindly respond. I'm not getting you on view. Okay. Thirdly, I would like to say Mr. DJ Gohain, the person from Textile Excellence, shortly to say that it is an excellent tabloid, excellent paper for us to understand the entire gamut of textile industry. Consistently, he is contributing nearly around 18 years or 20 years, Mr. Gohain. Your microphone is off, DJ.
Yeah, it is 20 years running now.
It is 20 years. So it's a lovely association with us. As all of you possibly quite familiar with me, that I am also associated with the textile industry over the last nearly 40 years. And he is the alma mater of our institution and doing very well in this particular field and contributing, assisting. He is also coming up with textile management, issue also very recently. Am I right?
Correct.
That's right. The slightly different approach, but the content is excellent. So I'd like to thank you very much to be with us, and we will look forward to have a wonderful association with you in the coming years. Mr. Kanoi agreed that he will be joining the inaugural session. Unfortunately, maybe he is not available. Dr. Abhijit, I want to Is he there, Gulane? Sujit, can you see? I'm not
Yes, sir.
getting.
Sir, Abhijit sir is there.
Abhijit sir is there. Pin him
Yes,
on the
sir.
screen. Abhijit.
I am here, Dr. Rakshit.
Yeah, please speak a few words.
Yeah, I am here only. Can you hear me?
Yeah, I can hear you now. I just wanted you to, yeah, that's wonderful, wonderful. Okay.
Sujit, can you hear me?
Yes,
Yeah.
sir. I can hear you, sir.
Yeah.
Yeah.
Speak a few words about the activities currently you are, engaged with. Particularly the particular survey report which has been recently completed by you.
Oh, shall I start now?
Sure.
Hello.
Yeah.
Am I audible?
Yeah, you are audible. You are visible. Please speak.
Yeah. So maybe my system is quite slow. Okay. Good morning, everyone. It's a privilege to get the invitation from Shirpur. And basically, IIT Delhi was entrusted by Ministry of Textiles in the year 2020 to conduct a baseline survey on the technical textile industry in India. So though we thought that we'll be completing the survey within a period of 6 months, the industry, and it was actually delayed, and finally in the last month we were able to publish our report. So basically the objective of this study was to understand what is the current status of technical textile industry in India in all the 12 segments, what is the consumption and production level, and what is the import and export level. We have and what are the skill gaps that is
Dr. Avit has a very poor connectivity and the bandwidth is very low, and with the background also possibly he is finding difficulty to connect. He is not audible now.
again somehow I got disconnected. Hello, Dr. Rakshit, am I audible?
Now, your bandwidth is very slow. I do not know
Yeah.
whether you are working on your mobile contact or mobile connectivity or what.
Yeah, I don't know. This is not very regular. Generally, we have very good connectivity in the IIT campus, but somehow today there is some disturbances. So basically, we conducted the baseline survey. We have also seen what is the status of R&D and education in our country. And basically, the objective of Textile Ministry is to give a very big boost to the technical textile sector so that this particular sector can grow at a rate of 10 to 15% in the next 5 years. And so that the total value of our technical textile industry reaches around $50 billion US. So that was the overall objective. So we covered almost every segment, and we have also done detailed study about 10 major players of technical textile industry in India. So it includes companies like Arvind, Welspun, and then we have Strata Geosystems, we have SRF, we have Garuare. So we have analyzed what is the level of their assets, the profit level, revenue generation, what they're doing. So that was about the study. I think the details will be released by the ministry after a few months. Thank you very much.
Okay, wonderful. Thank you once again. Dr. Tasneem, please have a few words with us, exchange a few words with us.
Very good morning to all the dignitaries and the dear participants. This MDP has been organized to talk about the future of the synthetic fibers in India. And really speaking, the synthetic fibers were engineered way back, basically to simulate with the natural fibers to bridge the gap between the demand and the supply chain. They were very good in terms of the technical parameters, but lagging in terms of the functionality. So at the later on stage, they were modified for chemical and the physical parameters to add to the low value functionality to make them suitable for the users. Hence, this development didn't stop at this end, and it was continued, and that has given the birth to the third and fourth generation of the synthetic fibers. They are the high performance fiber. With their introduction to the market size of the synthetic fibers has been increased tremendously. And they have penetrated in all the regions apart from the apparels and home furnishing, the low value synthetic fiber markets to that of a high value synthetic markets. It is starting from the agrotech to that of advanced aerospace engineering. Everywhere you are finding those synthetic fibers, starting from civil structures to that of the medical healthcare center. Everywhere it has been used, and that has added to the versatility of the synthetic fibers. The Indian players who are playing a leading role into the manufacturing of the synthetic fibers and related products, they have also adopted the latest technology and use the e-commerce platform for the trading and increase the span of utilization of the synthetic fiber into the worldwide platform. Even the continuing research has been promoted by the government of India, and they have taken the due initiative to establish the Center of Excellence, just like Atira is true for the composite, etc. is for the medical textile, and so on. This continuing research has given the good success in development of the biodegradable polyester and the polypropylene, which is, I can say, the step ahead towards the green revolution with the synthetic fibers, because they are blamed for their known biodegradability and thereby having a restricted use in the particular areas where the biodegradability matters and the natural fibers are always having the upper. Altogether, it put the India today to the second position as the largest manufacturer for the polyester and the viscose rayon, and the sixth position as an exporter for the man-made fibers and the related products. UAE, USA, UK are the major customers for our man-made fiber-based products. But still, the import figures of the man-made fibers and the related products make us to worry about, because that has also hiked in the last 5 years. The major reason behind is our synthetic fiber industry is mainly concentrated towards the low value added synthetic fiber products. As I've said, apparel sector, home furnishing sectors are dominating in this regard. And we have given the least consideration to the huge potential in the high value added man-made fibers, textile products. As sir has mentioned just now, that Arvind Limited has, like a company like Arvind Limited has already been started the initiative in this direction. Their plant at the Dholka and the Chatral witnesses there is a change, drastic change in the application field of the synthetic fibers. Second limitation of this synthetic fiber industry is that they are based on the majority of them are synthesized from the petroleum-based chemicals, and any fluctuation, just like in the present status, Russia-Ukraine war, can fluctuate the crude prices and thereby the price of the synthetics, affects the economy of this industry badly. Third is the concern about the environment and the safety of the humans at the work, because they involve the use of the volatile organic compounds, emission of the hazardous gases. So it is required that they should follow strictly the regulations imposed by the regulating body. And last but not least, the taxes, as sir has just now mentioned, that government has given a booster dose to promote this industry, but still they should be rationalized to promote this industry further, because this is going to be the proven to be the one of the most, I can say, large leading industry for the India in the future.
Thank you.
Finally, for concluding, I would like to say, when the entire world economy was trembling due to COVID-19, the economical imbalance was there, but still the synthetic fiber industry has registered 5% growth rate. That shows the strength of this industry and a bright
Wonderful.
future ahead. Thank
Yeah,
you.
wonderful, wonderful consideration of information, madam. Thank you so much. I'm seeing all our speakers are on the board now. I'd like to welcome Mr. Barot. Please put on your microphones on. Please put your microphones on. Yeah.
Yeah.
Mr.
Yeah.
Barot,
Good morning, everyone. Yeah. Good morning.
Good morning, sir. We will listen to you very shortly.
Yeah.
Mr. Nevatia, Sandeep, you are also there. There are two Sandeeps today. One
Yes.
is Mr. Sandeep Acharya. Hi. Sandeep,
Good.
please put your microphone on. Acharya.
Good.
Yeah.
This is Sandeep Nevatia. Sorry, I am Sandeep
No, no.
Nevatia.
That's what I said. There are two persons today. Nevatia, thank you so much to be with us. Wonderful.
Thank you for
because
inviting us. Thank you for inviting.
Same. We are also honored that we'll be able to listen from the uncommon applications. You can hear, if you were there from the beginning, you have already heard that Dr. Majumdar, who has been doing on the baseline survey. And I would just like to passing a remark about this particular thing, although it's a part of the concluding session, that Dr. Abhijit, you are there on the line? Yeah, you are on board. Okay, fine.
Yeah, I am here.
Organized sector do contribute for the technical textiles production, manufacturing, and to some extent research. I do agree. But the point is that the exact growth is there from the non-organized sector. Many companies are there functioning or working in this particular area, knowingly or unknowingly, for over 30 years or 25 years, and they are hugely contributing for a major segment of technical textile applications in India. I'm sure that your baseline survey will talk everything about it and already taken into consideration. Thank you. I'd like to welcome Mr. Sandeep Acharya, who is at the moment he is not in the country, and he will be talking on the BCA technology. Mr. Acharya, hearty welcome to you on this program. Mr. Acharya. Currently, he's talking or he's meeting us from Uzbekistan. He's an international consultant on this particular product group. Thanks for a career in a particular group of textile material. So we will listen very carefully. He is the first presenter today, and we will listen from you. Mr. Acharya, if you're there, please. So I'd like to do not take much time. It is already 10 minutes to go. I'd like to switch to Mr. Gohen, who is handling the media part of the textile industry for nearly 2 decades. Please comment your observation for overall structure or the overall, achievements of the textile industry, because you people are consolidating the information from various corners, organized, disorganized, decentralized sectors, and secondly, especially for synthetic fibers. Mr. Gohen, please.
Thank you, Dr. Raksit. Just to give a background, I have worked in the polyester and nylon industry in my early stage of career before switching to media. So from basic engineering to detail engineering to erection and commissioning of polyester plants, and up to the customer service level. So this is something, synthetic industry is something very near to my heart, and I have been following the Indian synthetic textile industry, especially manufacturing side, very closely since 1995, I can tell you, I have been following this. It's a phenomenal growth, and our sheer population needs synthetic fiber because cotton is not good enough to cater to the need. So we are now today, as Dr. Tasneem has said, we are the second largest producer. But the difference between China and India in the rank 1 and rank 2 is too much. We produce around 8% of the total global production, whereas China contributes nearly 66 to 67%. So that means we have a huge road ahead to cover, because we are still competitive in manufacturing any synthetic fiber in the country. For that matter, Indian industry would grow further. And I guess Sudipto would agree.
Yeah.
So, and not only India, in the South Asian region too, in totality, we have huge space to grow. There's a demand-supply gap, and we need to cater to this need. So this is not only the commodity that we are producing at this moment, but we also have specialty and functional fibers. And that's what we are still, some of our companies have been producing some of the specialty or functional fibers at this moment. Say, for example, I could tell you in 1997-98, dope-dyed polyester was in fashion. I mean, people just started making that. Now today, at that time, it was a specialty, but today it's a commodity. So like that, we'll see a lot of specialty and functional fibers, like wicking properties, that inherent wicking properties, stretchability, that bicomponent section. Then we also have seen a lot of FDI growth here, tremendous growth in FDI sector. So Indian polyester and nylon and polypropylene industry will grow into this sector in the coming future. Possibly next 5 years, we'll see a lot of new specialty and functional fibers will come to that space. I don't say that we don't have, but it's going to grow. Say, for example, technical application. I am now working on developing a product, basically import substitution. We have developed it now, which is, we were importing around 1400 to 1500 crores every year. And it's a very simple thing, I don't want to name it here, which can be manufactured by very small guys even, but it was not developed. But today, we have developed that fiber, developed that product, not the fiber. Fiber is the basic fiber, which is high tenacity fiber. And it's a shortcut fiber, extremely shortcut fiber, which we have developed now. And it can replace the import, as Dr. Tasneem ma'am said, that import is a bit worrisome. We are importing most of the specialty fibers. Commodity, we are not importing much. So these are the specific product groups that we can target and develop import as an import replacement. That is going to happen, and it has already started. Since we are working on a project, there are many more people are working on similar projects. So future is specialty and functional fibers and technical fibers. Then comes recycling, very important, very, very important. We have quite a good number of recycling factories. We have around 39 polyester bottle recycling plant and who are making staple fibers. And Sandeep from Polygenta is already here, so he knows they are one of the pioneers into making.
Very good. So that's why how Mr. Nevatia got into the loop, because I had a dream to take Polygenta on board. This is just to listen that how the recycling industry is moving.
Correct.
Sandeep,
Thank
we'll
you.
listen from you.
Yes, sir. Sure, sir.
Yes. I'd like to say one thing, that all the speakers are there on board now. Mr. Biplab Chakrabarty has also joined, a tyre cord expert. Sir, you are welcome. We will come back to you. And Mr. Sudipto Mandal is already there. Sudipto will speak a few words a little later after Mr. Gohin finishes.
Thank you, Doctor. Thank you for the invitation, and good morning to everybody.
Thank you.
So recycling is another thing, and this is not only recycling. We have to look at circularity, basically bring that recycled product again to the production chain, and that's a lot of work has been going on globally, and India is not going to away from it. So circularity in synthetic fiber recycling is going to come, and that's another area Indian industry would work on in the future. And lastly, but not the least, now polymers can be produced from bio-based raw materials. Say, for example, polyester is the major part of it. 86% of PTA is required and MEG is required. So MEG already we have a bio-based source. Even now PTA is developed from bio-based source. Similarly, for nylon, adipic acid and caprolactams are being developed from bio-based source. So those are the areas Indian industry will look at, either adopting the technology from the foreign or developing their own. So this is how I see the Indian industry, synthetic industry would grow in the future.
Wonderful. Thank you, Mr. Gohen. And it's a wonderful insight about the future, especially from the bioresources. I think we should organize some kind of, a session on this, because this is really, I personally believe that's an emerging area, extremely emerging.
Exactly. And so, very fascinating.
Very fascinating. So people have to be well informed about this kind of developments, and it will be beneficial for each and every stakeholders of this industry. Thank you so much once again to join us in this session. I'd like to, because all the speakers are there, therefore, Sudipto, if you are there, just say hello.
Hello, sir. Good morning.
Yeah, good morning. Good morning. You're welcome. See, the understanding everything is okay. Whether you recycle or you produce or you make something new or reinforce with something, that's a different thing. But 4.0 is the keyword.
Yeah, true.
All the machines are now not working in 1, 2, 3, 4.0. It is 4.0 today. So we are eagerly waiting to listen from Mr. Sudipto on this particular subject. Very young, energetic engineer with Barmag, I should say, right?
Yeah, Oerlikon you can say, because I'm representing all the brands, Barmag, Neumag, and non-woven.
So we'll just wait for some time so that when he will be speaking on this particular very fascinating area once again. We are exactly 11 o'clock by now, and Mr. Acharya is the first person to speak with. I would like to hand over the control to our coordinator of the program today, Mr. Ranjit Turukmane. So please go ahead with the session's beginning. Thank you so much. Thank you everybody who has joined the inaugural session once again from our side. Once again.
Yes.
See you in the concluding session. See you in the concluding session. As far as possible, my request to all the speakers, if you can join us at 3:30, we organizing in a way that when the students, when any person register, they have put up a few questions, which we have already sent to the speakers to be, remain prepared about the thing. Besides that, if any of the students or any of the persons have any questions, we can do it online, no problem. So thank you very much once again, and putting it to Mr. Turukmane to go ahead with the program. Good night.
Yes, sir. Thank you, sir, for encouraging all of us with your valuable words. Now, I would like to invite the most distinguished personality, respected Dr. Akshay Malhotra, Director, NMIMS Shirpur, for Chairman's address.
I think, I would like to speak. Some time back, he had telephoned me to say that he has a meeting with the Vice Chancellor's meeting, which is scheduled now, and therefore he will not be able to participate in the inaugural program, 11 o'clock onwards. So he has welcomed everybody and sent the good wishes for a successful execution of today's MDP. Thanks for
Thank you, sir. Yeah, thank you, sir. Now the inaugural session is over, and now we'll move to the first awaited expert session by Mr. Sandeep Acharya. He is an international consultant, BCF Uzbekistan, and he will speak about the development in BCF technology. So it's a great honor for me to introduce speaker for the first expert session. Mr. Sandeep Acharya did diploma in man-made fiber from Sasmira, BTech in man-made textile technology from DKT Chalkaranji, and masters in marketing management from Wellington Institute, Mumbai. Sir have very vast experience of 30 years in India and abroad. Mr. Acharya had worked with many companies, Nirlon, 4K Polyester, Reliance Industries, AT Enterprises, AYM Syntex, Welspun Group, and American China and industries from UAE and Indonesia. During this, he handled overseas projects on man-made fibers and polyester BCF. He worked for various key areas like operations, technical marketing, product development, business development, project R&D in UAE, China, and Indonesia. He played a vital role in setup of world's first project outside the USA of polyester BCF in China, Oerlikon. He was the head of R&D, new product development, textile yarns, and BCF division, AYM Syntax. Currently, sir working as an international BCF consultant in Uzbekistan. Now, I would like to invite Mr. Sandeep Acharya to deliver first expert session. Sandeep sir, is over to you. So please unmute yourself.
Yeah. Good morning, everybody. Thanks for all of you to give me opportunity to talk in this MDP. And it will be my great pleasure to participate in this MDP. In last year also I had a session with you and it was a great experience. Hope this subject will enlighten most of the audience and knowledge to them, because BCF once again is a not so common field in India, and many people are now keen to know and understand what it is. So let me start with my presentation straight away. So is it visible?
Yes, sir, it is visible.
Yeah. So the heading which I've given is like developments in technologies and downstream. Why I've included downstream is because not exactly like POI, but it is sort of intermediate product in some cases when you require value addition in the carpets and rugs. Process like cabling, it setting, and then it is being used in the carpets and rugs. So let me start my presentation. What is BCF? Basically, it's always been, said in a short form, BCF. Bulk continuous filament. Plan for this presentation. First is what is BCF. Also, I need to tell what is the historical background, because again, let me say once again that this being comparatively a new field to many of the people, technocrats, even Indian, because this field has not been so open in India and still it's a growing field. So historical background could help them that how this technology has evolved, how the fibers have evolved, how the multi-polymers have come into the picture over the years. So that's the transition of fibers in end applications. What was it historically and what's now and what's going to be the future. And then BCF technology as such in nutshell, how it is, and it's a global canvas, on a global canvas. Last point is straight. So let's start. BCF, bulk continuous filament. What is bulk continuous filament? Because the texturizing or bulking happens in the spinning itself. And why this? Because the end application is very specific where this BCF is being used. So unlike apparel, the end application and the features required for the fiber and the material are completely different. So it's a complete different field, and slowly we'll unfold what kind of significance features should be there in this kind of yarn. So basically BCF you can use directly in the carpet, or you can make a value addition by cabling, twisting, and then heat setting, and then using the carpet. So there are is an integrated process where the spinning and texturizing takes place at the one stage. This doesn't happen in case of POY or FDY. So this is a unique technology. Now, this is where I want to show the difference between the normal filament. Here, as already, it's a unique integrated technology. Spinning and bulking or crimping or texturizing, whatever you say, happens in one stage. The denier range is very high. It starts minimum of 700 or 900 are the most lower level deniers common, as the denier can go up to 3000. So it's completely different ball game in case of the coarse yarn, in case of the yarn denier and the structure. DPF of the yarn is
must have gone into NDMA. I have a very strong. I know it.
In the apparel sector is you go what everybody requires. There's like a soft, softer yarns are more required in the apparel sector, like micro denier and all. But if you see the historical background of BCF, the DPF is very high. It started 32 like that. So it's a very different sector and a very different technology, basically. The lusters are very common, like filament yarn, like semi-dull bright or super bright nowadays, what we call it. But full dull is not very common in case of BCF. And trial already there, but in case of normal filament yarn for apparel end use, you have multiple cross sections like pentalobal, octalobal, rice, and whatnot. I mean, but here it's more limited to the round and bright because again, end application. So you have to make a yarn, fiber yarn. As basic types of BCF produce basically raw white, which is mainly into nylon and polyester. Why? Because nylon also goes with solution dyed, but it also goes for printing, like a normal printing or a digital printing. So long lasting in utility industry like hotels, lobbies, or rooms and all that's of nylon printed. It lasts long, high resiliency. Monocolor and of course raw white polyester also is a trend, mainly in China, where they use modified polyester. Easy printable, printed like, because it's modified, it can be dyed and printed in less than 100 degrees temperature. So this was in fact a development which I did when I was with a Chinese company in China, and we produced their world's first easy printable polyester. And this was also produced in solution dyed as well as raw white, but PP all the time solution dyed because everybody knows that it can be dyed in the yarn form. So monocolor BCF is one type, where a single color in the yarn where you can use polyamide, PP, as well as even now RPT as recycled PT. And tricolor is another type of BCF where 3 different color yarn forms one yarn. And this is a desirable for various kinds of carpets. So tricolor is unique in BCF technology. So already told, here I'm mentioning like is equal to carpets and rugs, because it's a very specific application. And how it is like carpets and rugs, how it is evolved. Historically, if you go in 40s, 50s, 60s, like that, 70s, till that wool was ruling this most softer fiber, high resiliency, high abrasion resistance, FR, flame retardant naturally, and long lasting, durable. So wool, I mean, when wool was used, that means it was, the industry was ruled by the spun yarn. And then started with the synthetic fiber used in the carpets. So it started initially with the nylon 6, and then it was also taken over by polypropylene and nylon for a long time, till in last 1 decade the polyester entry happened. Various types of carpet depending on how, how is the application. I mean, like residential, commercial and contract. The requirements of the fiber or features of the fibers required for different types of carpets are different. Like in commercial, suppose in commercial where there is a high traffic, the durability counts a lot. Residential, where you may require a look, a feel, like that. Again, contract carpet, same, like you require a long lasting carpets, like where it is very common to have woven carpets, bed of even today, like long lasting, nobody changes it for 10 years, 15 years, like that it is. So different fibers and different structures, different type of carpets. Now seeing again the background, how it is evolving of the yarn. The first phase, it was spun yarn. Then the BCF started happening from 70s onwards, where the spun yarn is taken over by the bulk continuous filament. Initial technology was little raw, but this became popular very fast. And in 80s, till 80s, it was taken over, and spun yarn started taken over by the BCF. This was like old figures, but the projection up to 2020 for a face fiber in carpet in US mills, it can clearly tell where it was standing, like in 2005, 6 was 1. And now it is coming up something like 36%. So it is slowly replacing PP. You can clearly see on this chart how it is replaced, and the spun yarn almost have gone out of the picture completely. So basically, next big thing is the carpet, and that is how the technology also have advanced in last decade from PP nylon, PP, PS6, PS6.6 to polyester, and then to recycled polyester, and even the next generation fibers like Sorona, PL and all. See, this was a consumption in 2005, PT 1%, PP was 52%, PS66 was 22%, and PS6 was 25%. And now the scenario has completely changed. So there is a big point over the year. Polyester is a major fiber in carpet, which was earlier not seen as the real potential fiber because of its drawback. Nylon 6 has a high resiliency, polypropylene has a high resiliency, and tendency in the pile to stand straight. While poly is heavy fiber, difficult to texturize, the piles can slip or fall. So this was not considered, but with the advancement of technology, it has made possible over the year. So if I categorize in the 3 or 4 generations of BCF technology, now which is ruling, and it will rule for next few years. And next generation fibers already have entered into the fray, which are like RPT has a great demand, recycled PT, made from the bottle flex and converted into BCF, monocolor, tricolor, etc. PBT, Sorona from DuPont are making the transition to the next generation. Initial development, already I mentioned, wool was the superior fiber. Then it becomes nylon 6, PP, and this. Now, what was the major hubs of BCF producing BCF production? Initially, it was USA, where the Dalton is the area where you have a huge carpet factory, big players, top brands in the world like Mohawk, Shaw, Maples, etc. Bolio are placed, and they have huge factories. They have a huge carpet factories and a backward integration to the BCF technologies and extruding hub for the BCFs. But in 80s, like late 70s, shift started from shifting of the extrusion technologies from Belgium to the Turkey. And now, if you see, USA is still a big name and a big hub for BCF production in big way in polypropylene and polyester. China in all three polymers, nylon 6, polypropylene, polyester, and even RPT now. Middle East also, like Saudi, Abu Dhabi, Dubai, UAE, I mean, and then North Africa like Egypt, Oriental weavers, they are the CF producer, I mean, countries. Technology suppliers, like if we talk from the historical side, Rieter and Neumag again was the main players initially. Also, there were some Italian manufacturers like Filteco, STP, Implantier, I mean, so Parisian main. Rieter, which is now taken over by Truzler, Swisstex, taken over by Truzler, and Neumag, which is known now as Oerlikon Neumag. These are the main players, while SML Ostrophil and Vanderbilt in the this fray, and these four are the main players in the BCF technology. Market leaders, if you talk even on today, I would name Oerlikon Neumag because last 10 to 15 years are being installed by Neumag, and the major chunk of it is you can say 80% of the lines must be polyester lines than the PP and the nylon. And Oerlikon is the major company which have brought in marked innovation and upgradation. Of course, Truzler also has come up with a line which is in JV with Erema. But the in next few slides we are going to see the generation of machines offered by Oerlikon over the years, and you can see the changes very easily in a really marked way. Because I have witnessed it 10 years back when I was in China, we were using first generation lines for polyester like S3, which was made for polypropylene, which we modified a bit. And then we were using the same lines. The productivity, the efficiency was not like what you see in the latest lines of Oerlikon. So marked improvement is offered by Oerlikon, and the results are clearly seen. And this is driving more and more towards polyester. Now, if we go into the components of the BCF, basically few things are very common in like what you have in the filament yarn or fiber industry. Is chips press or granule press? When you are using PP, granules, chips for PS6, PS66, and polyester and other nation fibers. It's an integrated chip technology, spinning and texturizing in one stage, monocolor and tricolor. Tricolor is monocolor, of course, everywhere we use fiber, more unique because of the end application requirement. And it's basically BCF plants come in a very compact modular designs, easy to install and easy to commission. Quenching method is being used for most of the technologies offered by Oerlikon, Truzler, or whatever. Texturizing method is like a stuffer box, what you can call, but like called as friction texturizing or a stuffer, because here the friction disc texturizing process is not possible. So this is also a texturizing zone in this technology. Then the tangling or air tangling unit, what we call it, the entanglement pressure, because the yarn denier is very coarse. Yarn path, basically a bit bit complex than normal because of the bulkiness of the yarn and the handling of texturizing on the same process and the tangling. So sometimes the yarn path is not same in the older lines, but now the technology is improving the yarn path to the great extent, making it more and more straighter, reducing the tension, so on. Initial transition I want to show, because again, this will give an idea how the world has moved. Initial lines were capable of lower speeds like 2000 meters per minute, 2200 meters per minute. Texture design was not like up to the mark as on today. So the bulk levels were maybe you can say lower than what you see today. And most lines were having lower production. They were like 2 end lines, 2 position lines. So 2 end per position, 2 position, 1 line. Like that, the length of the line was. Now that next generation, what happened? I mean, the change occurred was like spinning speeds got up to the like 2300 to 2400 meters per minute. Texturizing technology improved. Yarn path drastically improved. Efficiency lines which was offered, like there's a modular design. This is a Trussler line. Now, what is today's BCF technology? The speeds exceeding 3500 meters per minute. So high productivity. Line can, the most important the line with the multi polymers. 10 years back, this was not possible. If I was to buy a line for polypropylene and polyester, then different lines were offered by the suppliers. Because now the line is configured in such a way that you can run polyester, you can run RP, offered due to the technology advancement over last 10 to 12 years. So bulk levels exceedingly well now, like we will talk about the latest technology from Oerlikon, which is S8 line or S8 machine. Extremely good bulk levels have become possible in polyester now. And higher number of positions and ends, so higher productivity, higher efficiency. What are the drivers basically last 10 years or 12, 15 years drivers which have driven the industry to the different level? Basically, initially, as I mentioned, DPF was wet in the carpet, and the typical deniers and typical DPF were used, like 2400 denier, 120 filaments, 144 filaments with very high DPF. Now, last few years after entry of polyester, demand has changed. People have started asking more soft yarn. We want softer yarn. We want softer yarn. It means the DPF has gone down. DPF has to gone down. If DPF has to gone down, then there should be a marked innovation in the technology is demanding. So these were the drivers. Then the higher productivity consumption. This where everybody is looking for the lower operating costs. So these are the drivers over last few years which have driven the industry on a fast track and towards completely different products and completely different polymers, especially like polyester. Why? Because people are demanding soft for the carpets and rugs. Oerlikon, how the technology has evolved. Basically, S3 was the line initially offered for PP, PA. We also use this line in China. Next line came like S5 basically, which was a much better line for improved yarn path, improved efficiency, speeds, which was installed for polyester by many, also used for PP. S plus was a breakthrough again, where yarn path and the tangling unit, revolutionary unit where the energy consumption was lower than the traditional jets. Then came the S8. S8 is the unique technology especially excellent I mean applications of polyester in carpet, because see why nylon and polypropylene are always preferred, apart from their resiliency and the basic characteristics long lasting, but carpet manufacturer will always demand lower number of lower kg of yarn per unit area. So basically this means your bulkiness, you give higher and higher bulk, better and better acceptability at the end application. Carpet man achieved with very high speeds, high efficiency up to the level of 99%, monocolor, tricolor handling capability with very specific technology also there for a compacting of the colors like CPCT. What they call it as bi-component was never thought in BCF, and AYM I think is the first company who installed bi-component line, side-by-side type of bi-component line, and produce various type of bi-component yarn. This is a breakthrough again, because talking of bi in BCF, so various demanding demand in application areas have prompted this kind of technology evolution, and these are the technologies now available, and this will rule for next few years. I don't think there are many bi-component lines. Is the only one or maybe one or two more producers in the world. So unique lines. Now the evolving of the technology is toward real good for the carpet industry. Synthetic was their older offering for PPT. Then they have now come up with the M20, like 2-end lines, 3-end lines, or 4-end lines. So there were options for various kinds of demand from the market. If you want to end, also there are special offering for the RPT BCF operation with the JV with Arema. They offer the line specifically for the recycle flex-based polyester BCF. Let's go to the asset. I have already mentioned the features. One more feature bigger is after the texturizing, it's the cooling which happens in the BCF. I'm going to display the figures and a line, but let me first explain. The cooling is after the texturizing, you need a cooling of the yarn, where lugging of the it has got a bigger cooling drum than any other lines in the history, 800 mm dia, because then it's a it has given a higher dwell time, more relaxation, very well development of the bulk dimension. So these are the unique features of, and which is driving the line, driving the manufacturer to install this next generation lines from Oerlikon. I've already mentioned the drivers. Drivers of the demand are like softer requirement, and so now what is in offer? We were talking of the 8 to 30 kind of DPF. Now people are demanding 2 DPF, 1 DPF lines. Imagine the transition. It's difficult. It's not so easy. Not so easy to handle, because it's a technology difference. Very high per unit area, surface area when you go low DPF. So there are challenges, but already the suppliers have come up with the lines to offer a production of 2.5 DPF. We already produce 3 DPF. AVAM we already produced with PT even in RPT. But these are the lines. These are the lines we produce on S+ lines. But now the lines see the demands now. Traditional number of filaments, I mean spin rates offered was like 70, 90, 120. Spin rate offer are 240, 360, 500 holes. So if you produce a yarn like 1250 or 1000 by or 1250 by 500, like 2.5 DPF yarn, this is being offered now because of the technology advancement. So excellent bulk levels in PT. Because it's a heavy fiber and polypropylene the lightest fiber. So it was more easier to texture nylon and PP than the polyester. So the bulk achievement of today's bulk level, that is where the key or game changer is. This is the asset line, what it looks. You can see the texturizing unit, and below that is a cooling drum, and then the yarn goes for the winding. So the yarn path, as I mentioned, is little complex because you need to draw the yarn like a FDY between the DO goddets, hot goddets. Then you need to tangle, you need to texturize, tangle, tangle, texturize, then winding. So the process becomes linear than your pure FDY. And the line configurations basically in the winding or take-up section. This is another angle, what you can see of a closer look of a asset line, where you can see the texturizing unit below is a cooling drum. As I mentioned, complex, but because of the different processes it has to undergo. Cytec 1 is another unique offering from the Oerlikon. This is single end spinning. I mean, here the denier possibility is one position, like that it is a line. Unique for the unique products or specialities, or even for the higher efficiencies, higher processing speeds, high speeds, and its pack is unique. The spin pack is different from the design from the other line. Because of the specialized pack design, it's a lower dwell time of polymer in the spin pack. This is Cytec 1, what you can see from the outset. It's like single end, single position. You can install number of ends. Like this in previous generation than asset. This was S+, which we have in AVAM, I think in Bikelan also. So Indian companies like AVAM, Bikelan are the leader. AVAM is the leader of going for a BCF drive in India. Before existing in the north of India in Panipat region, but there was no expansion really happened over the period of last 15-20 years. But now it's driving, and I've learned that more and more projects are coming for BCF. Even European manufacturers put their shop here for the manufacturing of BCF and carpet and distribute all over the world. A very different yarn path in S+, just for the information. Now monocolor, everybody another unique tricolor. I need not have to mention whether everybody knows a single color in yarn. Now tricolor technology is what actually you get 3 different colors of yarn and then it combines into one yarn. Why? This is it gives a unique look. When you cable it, unique look in the carpet, and it was in great demand before. Though you will not see multiple lines in a any BCF installation. Maybe if you have 10 lines, then maybe 2 lines could be of tricolor, 8 lines could be catering to monocolor, like that, but tricolor yarn. And it has a unique look, which is a uniqueness in this BCF in carpet sector, which you don't see. What you see in moreover in a FDY, PY, DTY technologies, space dyed yarn. And but this of technology offered from number of years by the technology suppliers like Barmac, Swisstex earlier, now it's Truzeler, and SML Ostrofill from Austria. This is one of the unique feature of a BCF technology. In heart, what you can say of the line is texturizing unit, which is imparting the bulk, to the yarn. And earlier, modern texturizing unit handles high pressure. Earlier texturizing units were similar, but so the bulk levels efficiencies was different. Air tangling unit, their marked improvement have offered, already mentioned Rotec from Oerlikon, which gives almost a 10% less air consumption than the previous jets tangling jets. This was I to those who have never seen the BCF lines technology, how the texturizing or how it takes place. Like if you see from the top left, entry of the yarn, and these 2 channels for the hot air, and like this, the yarn is this is the cross section, and this is how the yarn is stuffed in the texturizing, what we call it as a lamella chamber, and the texturizing unit. So these are the basics of texturizing, how it happens in BCF. This is lamella. If you see the vertical, you see the basically the yarn is stuffed, but from both the side, like the hot air is channeled, and then when it comes out of the texturizing unit, it is a bulky yarn. It has a crimp, and then it goes around the cooling, like what you see what you see in a cardiogram, like that kind of structure of the yarn you can see when you see from the outside, and then they then it is taken to the winding. So these are the very basics. I'm just touching, not going into the lot of technicalities in the structure, design. A lot of things have happened over the years, but this is what the basic principle, or how the BCF, how the integrated technology in the spinning itself, the texturizing unit works. This Truzeler texturizing unit, this is a unit. Basically, same concepts are moreover same. This is how it the Truzeler line, or original, this is a Swisstex line, looks. If you can see, cooling drum is much smaller in diameter in the older lines, and the box which was called as HP texturizing unit in case of texturizing. So these are the different kinds of methods used, but basic principle remained almost same. What you call it as stuffer box or friction texturizing. But not with Rotec. I have mentioned already, so no need to again mention it. Now, when we are talking of BCF, what could be the next level? What way we can achieve more functionality, more value to the color is the one part, mono tri. So you have a master batch feeders already installed on most of the lines. So functional master batches like antimicrobial. We have done a lot of work in AYM. We came out with unique antimicrobial BCF products. And cannot talk much of it. What is it? Because these products are getting patented by AYM. But a lot of work we did on this, and the unique antimicrobial BCF we have produced. Lot of possibilities in this area to make more functional, just not a colored yarn, but impart more value to the yarn with respect to the functional master batches. So huge scope in this area, I believe, in the future and now. So FR, antimicrobial, like polyester, soft fill, is it possible through a master batches rather than just changing the DPA for using some other processes down? Possible mechanical modifications means, I mean, again, like you twist it, heat set it, and this is all possible over the period. Demand of now what is happening is, now what's the current rise? Everyone wants to make a green product where the recycled PT, BCF is going and coming more and more into the picture and in production. PBT, Sorona are having very low consumption. But their existence is a very small area right now, but may grow in the future. Now, once we talk of BCF, I already told BCF directly used in carpets, bath mats, rugs, etc. But when you cable twist it, you make a value addition. You have another choice to make it another value addition, like you can make a straight hit set or you can make a freeze. I will come to the slide where you can see the difference, how it is, freeze and straight. So this gives completely different look to the carpet, feel to the carpet. Appearance completely changes. But higher pinpoint effect means because the carpet is used in a, not unlike apparel, it's in a vertical form. So when you look from the top and side. So completely different requirement of the look and feel and appear. Facilitated this to impart more functionality to the BCF. So this is I'm not included cabling heat setting machine, which is very common, mainly supplied by Folkman, again from Oerlikon. This is another BCF because this is a heat set machine, entirely different from usual autoclave or a normal DTY, FDY heat setting. It's a very long machine where you have a long heating chamber. The yarn passes in an open form on a conveyor, and there are different attachments, and then it's again wound on the winders. So this is a Superba machine, TVP3. Now it is Superba, originally a French company, now owned by, taken over by Vanderbilt, Belgium. So it's a TVP3 line, very popular line by suppliers of headset machine like Superba, power headset from Germany. They use a different type of steams. Like one uses, one can offer you with the saturated steam, one can offer with superheated steam. The effects are different. One can give you another give you very good density in the carpet. So depending on what you want, what you desire in your carpets and rugs, the people use the technique downstream, different techniques of heat setting, and make the yarn as per your demand. The heat setting, cabling and heat setting possibilities. You can impart different twist levels, SZ, SZ, and then straight and freeze. See, when we are talking of a straight heat set yarn, this stands like this when you are using in a carpet. This is a cut pile. Whereas the look will be straight pile strand of yarn in the carpet, you can see. When we talk of freeze, this is how it gives. It's like give a curly effect to the yarn, and the carpet, what you can see is like having this kind of look. So entirely different look is possible through the heat treating process. Unique, and it's the heart of carpet overall yarn chain for the carpets. So this is just for showing you the effect, how it is in brief. This is freeze effect. This is a rollers lines. This can be offered on both the lines from this thing. And with this, I think I will conclude my presentation. I hope it was little informative or interesting to the audience, and hope it can.
Yes, thank you, sir.
Generate, may have ever seen this or entered it. Thank you so much to everybody who have given me opportunity to talk. Thank you so much.
Yeah, thank you, sir. Thank you, Sandeep, sir. Thank you so much. Thank you for sharing your experience and technical details and sparing your valuable time with us. All of our participants may definitely benefited with your expert session. So let us now move to the question.
So I tried to concise it.
Yes, sir. So now we'll move to the questions from the audience and the discussion session.
Okay. Okay.
Sir, I have shared the questions with you. Apart from that, I will read the question. So one question is on this year. What is the future of synthetic fiber?
Okay, I'm not able to
considering sustainability.
Okay. No, I can't see the questions. You can tell an answer.
Sir, what is the future of synthetic fiber considering sustainability?
Again, I will repeat. The future is in polyester, and in case of sustainability, greener fiber like polyester, nylon, but the consumption levels on polyester demand will grow multifolds. But there is some advancement in the technology is required. The reason is, when you are using flex, the source is not uniform. The distribution is not uniform, and filtration level, lot of impurities. So there are challenges in this technology. There are challenges, but I think the technology suppliers are working continuously to make it better and better, to make better green product in future. But nylon, already Aquafil is offering green nylon, Econil. But polyester, I think, will be a future in RPT, and I think it has a great future. More and more companies are asking for greener products.
Thank you, sir. There is one question
in this greener carpet. Yeah.
What are the chances of regeneration and use of tuft carpets?
What are the chances of from tuft?
Regeneration and reuse of tuft carpets.
Yeah. Most difficult thing actually, and yeah, I understand this is the most difficult, in fact, question or topic to the all carpet manufacturing countries, and carpet using countries, because it goes in the, and all the carpets mostly of synthetic, not biodegradable. But whatever I know now, only Zimmer has a technology to recycle carpet. No other technology I've seen and it's very costly and complicated technology. The reason being, there are various components. There is a secondary backing, there is a latex. So a lot of components are the challenges to separate and recycle. So it's a very challenging thing, but hope in future it should come up. But Zimmer, I can recycle, and it's a big question mark to everybody in the world. Which countries you are using carpet? Landfill is a big problem.
Thank you, sir. One last question.
Okay.
Which synthetic fiber will lead to the future?
Can you repeat? Can you repeat? The internet connection was weak. Yeah.
Yes, sir. Which synthetic fiber will lead in the future?
Which synthetic fiber will
Lead in the future.
lead? Polyester, no doubt.
Undoubtedly polyester.
Polyester, because already a technology supplier itself, yeah, that they will tell you polyester.
Yes, sir. Thank you, Sandeep, sir. Thank you for the encouragement.
Actually innovating, in terms of technology and solutions throughout this 100 years, and we are still on the verge, like we will be still innovating throughout and will be the market leader for next 100+ years, I would say. So when I talk about Oerlikon, it's a global high-tech engineering group with unique competences. We have our leg or foot in different areas like advanced materials, surface solutions, and material processing. So this is an overview of our divisions right now. We have two divisions, that is surface solution, and another division is polymer processing division. So I am from polymer processing division, basically, which also had a MMF, man-made fiber unit, as well as flow control solutions unit. So under man-made fiber, we cater to the entire synthetic fiber industry. So the main markets, if you see, like under polymer processing, our end markets are more or less focused on apparel, functional wear, home textile, industrial applications, automotive construction. Okay, so do you have different solutions and technology offerings in terms of spinning, texturizing, non-wovens, polycondensation, CP, like polymer processing, staple fiber, flow control solutions, and all. So we will go in a short overview. So this is the financial week. I don't want to go into this. So basically, if you see the slide shows over here, so it shows a DNA structure. Basically starting from continuous condensation polymerization, and we deliver all solutions for yarn, fibers, and non-wovens. And this is the new term which you can see, clean technology, smart factory. Clean technology is more or less in order to reduce the carbon footprints in the industry, and smart factory is nothing but it's a part of industry 4.0 solutions, basically. So we are already part of industry 4.0 solutions, and we are almost ready with all different types of solution, which I will take you around, and what basically the MF industry has basically. So basically, Oerlikon, if you see, serves the needs of better functional fibers. So more or less, as we are into different areas, like medical and filters, infrastructures, apparel and functional wear, flooring, transportation, packaging. So are produced generally on Oerlikon machine solutions throughout the year. We are as I've already said, we are the market leader. We are the global leader in terms of man-made fibers industry. Like we have catered maximum machines to this industry, and we have a very huge chunk of market share in this industry. So we can provide complete engineering plan solutions, one-stop solutions, starting from melt. If you see, this is the CP over here, and from there, basically, you can see these are the POI and FDY plants, spinning plants over here. Then the melt can also be diverted for the PSF, basically. These are the PSF lines, basically, and again from the POI, the yarn, basically, POI is normally partially oriented yarn, which has to be texturized. So it goes into texturizing. So if you see, a company is of 24 times of football field, basically. So that's a huge plant, basically, and we can provide a complete solution, turnkey solution, for such plants. So as you can see, basically, like we are from melt. This is basically showing a CP over here. This is what our plants look like. This is the shop floor, basically, the winder level, take up level area of a filament spinning. Yeah, and these are the normally the POI winders. This is a DT1 machine over here. So these are the FDY machines. These are the winders of FDY machine, fully drawn yarn. This is BCF, which was already talked in the morning. There was a session. Then this is a PSF plant, how it looks like. This is a non-woven factory over here. So we are in complete polyester value chain, more or less. So if you see generally starts from crude oil, basically, from where the naphtha is being distributed. Then there's a ethylene process. Basically, the steam cracker from ethylene, like the MAG, is being manufactured, and then again from aromatics, from paraxylene, basically, yarn. Also, like delivering chips for different applications like bottle grade or film grade chips application. And in terms of yarn, we are getting to the all end markets like apparel, home textile, and technical textile. So this is a brief overview, like it shows you like our entire product chain. Though it's not complete, I would say, because now we are also focusing on the recycling also, and I'm taking much care of that portion. So basically, more or less, I'm handling all of the product portfolio you can see over here. So when it comes to like CP or extrusion, from there it's being distributed again to from CP. If you see like filament spinning, staple fiber, and non-wovens. Filament spinning, we have like in POY, partially oriented industrial yarn. BCF is bulk continuous filament yarn. Then from PUI it goes into texturizing. Then we have compact spinning machines, where you don't need to construct huge buildings and all. It's basically you need to have a shop floor, and these are 4-6 position machines which can be erected on steel frames. In terms of staple fiber, we have options for different types of staple fibers, basically cotton type, hollow, basically bico staple fibers. In terms of non-woven, we have options of ALA non-woven machines, melt blown, spun bond. And apart from that, there are special winders, gear meeting pumps, extruders, and offerings from our sister concern BBE. So more or less, the recycling solution is right now offered from our sister concern BBE, as well as our counterpart, basically, that is OBHE, Oerlikon Barmag Hutong Engineering in China. So now coming towards our main targeted area, that is man-made fiber MMF industry 4.0. So this is the talk of the current situation right now. If you see, first of all, I would like to elaborate on what is industry 4.0. So if you are seeing my slides, so generally industry 4.0 is the future, basically, in terms of smart solutions, in terms of solutions which will help you to gain insights, to run the factory basically remotely in future. So if you see, it includes lots of areas, basically augmented reality, like with there are cloud solutions where that data will be more or less stored on the cloud and can be accessed anywhere remotely, basically. Then you have cybersecurity. This is not a part of for sure our MMF portion, but then we have this big data analytics which will also be a part of MMF, basically. Autonomous robots is having a major share right now in industry 4.0 for MMF industry. So I will just take you around. I have shown some videos. Basically, I have added some videos to this, so to make it more interesting, and so that all of you can get a very good insight of what MMF for industry 4.0 is and what solutions will be there in the future. So this you can see, basically more or less your entire plant basically can be automated, digitalized using industry 4.0 solution over here. So entire spinning, whole factory, I would say. It's not spinning. When I talk about spinning, it's only refers to this area, basically. When I talk about melt, basically direct spinning, so it refers to CP as well as the spinning. When I refers to extruders based spinning, then there's no CP involved. There are extruders, basically, and then you have the spinning machines over here. So a factory involves more than 2-3 types of different types of machines. So more or less here it's a complete factory package which you can see on the screen over here. So to control everything all together, to monitorize everything, so we have different solutions, so which is more or less industry 4.0 solutions right now. So if you see the more or less segments like melt, spinning, quenching, take up, drying, winding, crimping, texturizing, cutting. All the aspects of MMF industry is being covered basically by the Industry 4.0 solutions. So main key aspects right now in the industry is one of the thing is online services. I will go in details in next slides. Then we have plant operation center, POC 4.0, and then we have remote services. Now coming on the main part, that is remote services. These days, especially during this pandemic time, we have observed basically, it's very important to have remote services because we are anyway delivering the presentations online. We are anyway delivering the presentations online. We are meeting. We can do the meetings online and all. But what about services? Because this MMF industry is also not only sales but also a service as well as technical driven industry, where lots of technical services are required basically. So if you see, this remote services plays an crucial role in industry 4.0 solution. And because of this, in pandemic times, many companies, especially this MF industry, has been able to help the customers basically. If you see, more or less, the client software, client has a particular PC remote desktop over here, which is connected to their more or less all the equipments in the plants basically, interfaces of different machines basically. And then they have PLC programming, and basically control is given on to that monitor especially. And then the monitor is being connected to a cloud server basically, which is also again then remotely connected to our networks, and which can be accessed. It's not like we can access simply access it anytime. The client has to give us, because considering different clause, considering basically especially for Europe, the privacy clause basically, so we cannot simply access anyone's computer or laptop. So we need to first of all take the client's permission. And there are many softwares, like especially team viewers and all. There are different innovative apps in the market by which the customer client can share their screen, and you can access their screen remotely by sitting anywhere around the globe. And you can simply see what's going on basically. Simply the client's screen will be shared on your screen, and you can simply monitor what's going on in their plant, and what are the things where the issues is. He can remotely understand the situation and try to rectify, providing good solutions. Maybe like more or less he will try to provide a solution over there itself. If there are some software issues, the software modifications will be done remotely. And if there are any other issues related to breakages and all in terms of processes and all, then he can guide basically from remotely to the operator or the engineer in the plant. So this was more or less about Oerlikon remote services. Basically, this is the remote service which is being taken care in the MMF industry. DTY refers to dot texturizing basically, and it involves more or less false twist principle basically, false texturizing principle basically, if you see. So I will show you a small video where you will understand how online services helps in terms of texturizing and what are the developments in the yarn texturizing industry. Are you able to hear the sound over here in the video?
No.
Just one sec, let me play. Can you hear?
No.
Sound is not coming.
Just
Audio is
audio is not. Just one sec, let me. Yeah, I will just share the computer sound. Now?
Yes.
Yeah.
Service Online is new powerful tool for DTY machine of Oerlikon man-made fibers. No matter wherever you go, whenever you are, you can get the real status of your machines. We start the product life management from assembling of each machine. By scanning the QR code, we collect the machine specification, production time, and upload them into the system completely. How can we connect our machines to service online after machine is installed? Power on, Wi-Fi generated, connected to service online. Download machine software from data center. One-click installation makes your life easier. You can reach our service team via Service Online. With Service Online, we communicate with you easily and quickly. We provide you remote diagnosis and solve your problem efficiently. How can we provide value-added service to you? Service Online collects and analyzes the real-time data of our machines. Send out pre-alarm signal when detecting any deviation. Service Online makes a fundamental shift from reactive service to preventive and proactive service.
"在这个数字化时代，我们需要新的工具。Service Online 给了我们机会，引领我们进入新的数字化时代。我们愿意与欧瑞康携手共进，共赢未来。"
We enable the success of our customers, as always. New service, new business, new future. Oerlikon man-made fibers. Service online.
You're not audible, Sudipto. Unmute yourself.
Yeah. Sorry. I was on mute. Yeah. So I would say, as you have seen in the previous slide, more or less, this solution service online was for the texturizing part. Basically, the POI from the POI, and partially oriented yarn has to be converted into DTY. And for DTY, this is the service online solutions. This is a part of Industry 4.0 solutions, which we have right now. Now, Plant Operation Center, POC, if you see POC 4.0, this is the complete solution for which we are offering for your complete plant, basically, to operate, to control the plant, to see what's going on in your plant. Especially, this is for the plant heads, operational heads, and all. It can be used. It can be used at different levels for sure, but also it's give a management is not around you. And sec. I think there is some issue with this video. I will just play it from the folder. One sec. So plant operation center can be used to cover each and every areas, basically in terms of extrusion, in terms of spinning, take up, in terms of DTO machine. You see, whenever a products comes out in the market, basically these days, having a barcode, a label on the product, every product basically in the market, if you see, there are barcodes basically on the product behind of the product. So basically, you see the each and every line in the barcode has some data actually linked to it. So how these barcodes are generated in terms of MMF industry, this video shows basically how data at each and individual level is being collected. Okay, and then all the crucial data which are needed at the end, when your package is ready, you need to know basically from where this lot has come basically, and all other categories, whether this is A grade or whether this is B grade. Okay, what was the full DOF and all, what was the efficiency of the machine on which it was produced and all. So everything can be fetched through the barcode being generated. So this barcode, if you see, from each and every individual level, there will be a barcode stick, barcode line generated, and then this forms a complete barcode level, and which at the end of the day, when you scan, gives you an overview of all the data basically. Also gives you basically, whenever there are the multiple product running right now in the plant. So it also shows you basically, where basically, the DOF will happen at which positions, basically, which position is currently running at a better efficiency, which position is running with more number of breakages. Everything can be, like basically you will have a particular app and interface basically, which you can see on your mobile phone, which you can see on your tabs on your computer itself, and you can see everything over, like, by sitting at a place. You don't have to go inside the plant, open up the machine screen and go through what's going on the machine and all. So all the datas are transferred to you basically remotely, like wherever you are, basically it gets transferred to you. One of the benefit is, these days there are companies who have basically, their sites, production manufacturing sites at multiple locations. For them, to travel to different locations and keep a track of everything, especially for the owners, the managements, or the senior level people also, it's very difficult, to keep a track of everything at one place. Basically, they have to depend on, there's a dependency on different people, different services basically, and So we can help, to centralize everything basically, So everything can be centralized in future with the help of POC, Plant Operation Center. And you might be like you are located in India and you have plants in different places around the world. Sitting at your office in India, you can simply go through all the data, what's going on in your plant, and whenever you can again then give a feedback to the respective plant people. So why the production, there is a downtime, so much of downtime, why there's production loss, why there are so much of breakages. You can ask the people basically and get the solution accordingly. So this is all about POC. Now coming towards Oerlikon online services with Microsoft HoloLens. So this is the future technology basically which you will see in future. More or less, this was also launched in our ITMA last year, ITMA 2020. If you see, so HoloLens is more or less will help you to integrate. This is an kind of augmented reality kind of thing, which will also help in the Industry 4.0 solution. Let us go through this video and we will get a good insight out of what it is. This you can see is a PUI winder over here, PUI machine winder. So basically, HoloLens really works. Basically, this is the augmented reality we are working and which we have developed in with help of Microsoft. So more or less, the machine has sensors. The machine is connected to the PLC HMI. Machine is connected to the cloud server. Basically, there's a data center in a box which it is normally connected, and basically, there are cameras on this. And if you see this lens, which it is not just a glass, this you can see basically, if you have seen the Iron Man movies and all, you can see the entire things on your display. So basically this lens over here, black color lens, it's more or less act as a display to you also, as well as there's a cameras over here, built-in cameras, which also helps to connect to the server of this system over machine over here and transfer the data to this lens over here, and also which is also been then seen to our people which are remotely sitting in Ramshild or any other places like where our servers are. And as you can see, with the help of camera, the person operator can show us basically, our service guy basically, okay, he can go through the machine, and we ourselves sitting at our room, in different parts of the world can see, okay, what's going on. He can guide the operator then accordingly by seeing the machine. He can tell, okay, see, there's a issue over there in this place. Issues on the machines itself. So on a particular, if we know that this is the area where the issue is basically, so accordingly we share the data, we share the slides or the documents which can be seen by the operator on his lens over here, and accordingly he can see, okay, what he has to do basically. He can go through the data and he can do the settings accordingly on the machine itself. We can simply, we don't have to tell him, okay, these are the settings. We can simply show a video, we can simply show the settings over here on his HoloLens screen over here, and he can simply then do the settings on the machine itself. I don't want want to show the full video. Basically, it will take a lot of time then, more or less. So this gives you a good overview how the future is, basically how we are evolving in MMF industry, man-made fiber industry, and especially how what Oerlikon is doing in terms of developing this industry 4.0 solutions for MMF. Now coming towards Barmag automation. Automation now it plays a big role in the industry 4.0, if you see, because right now this industry needs a lot of labor, and especially the manual labor are not that technically skilled. Basically, basically if you go to many of the old plants, there you will see the operator are taking out this bobbins. Basically, these are the POI machines. So basically, once the DOF is formed, once the yarn is being finally wounded, and the DOF has to be taken out, basically, the hand has to be doffed off, basically. So operator uses his manual hands and all, and sometimes the hands are dirty, and also it also affects the yarn quality. So this is something, basically quality is one of more the focus in the industry right now these days, because the downstream industry is asking for a more and more better quality of yarn. For next, the cost efficiency, we need less wastages and all. So the labor availability is also less, as well as the cost of labor is also getting increased day by day. So that's why, so it also helps in effectively managing your cost, basically, more or less, because initially you have to spend on the investment on capital would be a bit high, but then over next 10-20 years you don't have to worry, basically, in terms of labor or cost. Efficiency is very good in terms of manual labors and all. There is not much of a good efficiency, I would say, but when it comes to machines, their efficiency is much better. Reliability, you can reliable, because what happens sometimes, if this position of a particular position here is being ready to be doffed off, but the operator is standing over there, he is busy, maybe sometimes talking over phone and all, and your doff is ready, and in order to reduce the downtime, and also that simply the doff can be removed out, because unless until the full doff is removed, you cannot wind another package over here, and you cannot place empty paper tubes over here on the next roll, basically. So for this, if the machine automatically senses wherever the doffing has, the doff is ready, it goes over there, it auto doffs the yarn POI packages or FDY packages, and then the basically this doffer, automatic doffer, it then goes to there are trolleys at the end, where they place this bobbins, basically, on the trolleys over there, and then the trolleys are being conveyed through the conveying system. Though conveying system are also automated throughout the plant, there are rails, there are channels through which the trolleys are being transferred. Then they are taken to the knitting and inspection, they are taken to the inspection areas where they are inspected, basically. Inspection for the sure, right, as of now it's being done by manual labor, basically, but they are probably uses proper gloves and all, especially when they have people have automation in the plant. And for after inspection is done, then it goes towards the packaging, where you have robotic arms and all, which helps you to lay this packages from the trolley on the pallets, and then from the pallets, then the fully sold pallets are being taken again back to the, I don't know what is this over here. There's something on my screen over here. Is there any chance to remove this?
Yeah, you can just click the page and reshare it.
Yeah, I have just removed this. I have cleared, yeah.
Okay.
I have cleared the drawings. Yeah. So this is a small stimulation how it basically works. Can you see my? Oh, sorry. So this you can see. This shows a small stimulation over here in terms of automations, how things are, how automated factory looks like. Basically, I will play the video. It's a small stimulation. You see, these are the automated doffer basically. These are the individual positions, POI, FDY positions. These are the automated doffer. They get the signals. Okay, this particular position, they are basically normally the doffing has been done, and basically the doff can be collected, and accordingly then they go over there and then they do the doffing. I don't know why this is coming. Yeah. You can see how the doffer is moving over here. At the bottom, you can see, these are being transferred again. Here the dropper on the left hand side, dropper is placing the POI or FDY bobbins on this trolley over here, and then once the trolley is full, the trolley is being taken, transferred to the different area. Yeah. So this goes then to the inspection area. If you see this trolleys are being moved to the inspection areas. And when the inspection is done, basically this goes for palletizing over, like basically the trolleys are being taken, and then using robotic arms, basically the pallets are filled over here. These are the pallets, and from there finally it's being transferred, it's being loaded, then the pallets are being loaded on the truck, and that's how the automation works basically. So complete plant automation can be done basically in MMF industry. Reliance has been using these automations from long back, and we are the pioneer. Like basically Otifa was one of the pioneer in automation. It was taken over by AC Automation Germany, and then few years back we took over the automation, and now it is known as Oerlikon Barmag Automation. Okay, so coming towards next thing is right now, as you can see on the screen itself, wiping robots. So as I said, robot also will be the future in the MMF industry. As of now, if you see in terms of filament spinning, there are spin packs, as you can see on the right hand side of the images. So whenever the yarn is drawn, after certain period of time, the polymer starts accumulating on the spinneret orifices, the small holes if you see over here. So it starts accumulating over here basically. The polymer comes over here, and then it affects basically, if those polymers, those lumps are not wiped, at a particular interval of time. So this then affects, you see these polymers is coming from here. And here if you see the filaments, the full filament strands are going, after quenching, after basically spinning and quenching, it's going downwards to the yarn duct, and from there it's being taken up to the take up. So this needs to be wiped off after a particular cycle, basically, after the particular amount of yarn is being, drawn from this. So nowadays, right now, it's normally being done by manual labor, but we have also introduced this wiping robot. Right now, we have supplied this to well-known polyester, and they are using this. So this wiping robots, it's normally reduces, it's improved the process stability, because there is a indication to given to this. There are certain set of time intervals set in this wiping robots, so it automatically cleans each and every processes after a particular cycle. Basically, in terms of manual labor, sometimes they misses up, basically, when the cleaning has to be done, and if the proper cleaning is not done, basically, of the proper spinnerage is not cleaned time to time, there will be yarn breakages, there will be issues with the yarn qualities and all. So this is affecting the industry, basically, if you see. So in order to increase the wiping quality, in order to reduce the break rates, so in order to get a better full bobbin, low waste range and all, increase the wiping efficiency, so this helps, basically, the wiping robots helps you in a better way. I will show you a small video. I will just, I don't know why this thing is coming up again and again. So here's a short video on wiping robot and its application in spinning. Here the wiping robots has cleaned this earlier, as of now also in the industry, normally more or less it's manual process, where say the silicone spray cans are used. First of all, the silicone spray is being sprayed over there on the surfaces, and then the operator cleans it with a basically wiping cloth, basically. So I will move on to the next slides, considering time constraint. So now this is almost the last topic. I'm coming to an end almost. If you see the aim for DTY in texturizing, if you see right now the dot texturizing, basically the tension monitoring is being done using OLT, online tension monitoring system. So the online tension monitoring system generates lots of graphs. Technical graphs are being generated on daily basis, if you see. So for human people, basically, to go through thousands of graphs a day is very difficult, and to understand what are the faults, why there is yarn tension, why there are breakages and all, to identify the root cause is very difficult. So in terms of this, and considering for Industry 4.0, this artificial intelligence manufacturing for DTY has been developed in the industry. Especially, this is our patented technology in the industry, and it helps you. Normally, like, you don't have to analyze the fault graphs. Basically, the operator or the engineer in the plant don't have to. So the system automatically analyze the fault graphs, and gives you an idea why and where the issue is there, and what are the root causes of the issues, basically, and it helps you to improve your processes. That's all from my side. Thank you for your patience and for listening. If there is any question, I will like to take that.
Thank you, Sudipto, for such a wonderful session.
Yeah.
And my sincere thanks to you for sharing man-made fiber and Oerlikon experience to deliver best man-made fiber industry 4.0. So thank you for sparing your valuable time. We are very much confident that you have imparted valuable knowledge among all participants. Now it is over to Rajshree sir
I think we are running with a constant of timing. So therefore, first I would like to thank Sudipto for sparing your time.
Thank you, sir.
Quite a busy schedule, and then wonderful insight about the industry 4.0. So basically, we need to understand many things what you had explained in this process, and because this is not a very common scenario for many of us, those who are practicing technologists in the industry of textiles.
Yeah.
But however, things will come. We are automatically able to grab the benefits of these kind of systems, processes, and of course the investment which needs a, if we look at the that is the major thing. So the political will should also come into play to make these kind of programs successful for the industry in India.
True.
Thank you once again.
Thank you,
to be with us. Let us move to Professor Turukmane. We can move to the next session. Once again, I would like to welcome Mr. Rasmi Shah, who has joined the session now. Shah sir, namaskar. Okay, he might be listening, but he's
he was there.
Microphone. Okay, thank you, Sudipto, once again. Ranjit sir, please
Thank you, sir.
go ahead for the next. Mr. Barot, I think, waiting, ready.
Yes, sir. Thank you, Sudeep. Now it's time for the fourth session of the MDP program on Geosynthetics in India by Mr. Manish Barot, Head Technical Sales and Business Development, TechFab India Industries Ltd, Mumbai. So before starting the session, let me introduce expert of geosynthetics, Mr. Manish Barot. Manish sir has a track record as a geotechnical engineer with a diversified experience in civil engineering and especially in geotechnical engineering. Designs, techno, marketing, and business development activities related to the geotechnical engineering products like various geosynthetic products, wire mesh products, etc. for various civil engineering applications for infrastructure which majorly consist of relating structures like reinforced soil walls and slope, ground improvement, pavement stabilization, pavement improvement, riverbank protection, etc. Mr. Barot have very vast diversified experience of around 31 years in civil engineering. From last 15 years, he is working in the field of geotechnical engineering. He started his career in geotechnical field as a design engineer in multinational company, where he worked for countries like France, UK, USA, Australia, and India for more than 10 years, and currently heading technical sales and business development team in national role in TechFab India Industries Ltd. As a head, technical sales and business development, TechFab India is one of the largest manufacturers of all geosynthetic products in India, where majorly the focus sectors are road, railways, and infrastructure. So about the educational details, sir did his Masters of Engineering in Civil Geotechnical Engineering in May 2007, first class from the MSU Baroda. Bachelor of Engineering in Civil in 2004 with first class in MSU Baroda, and Diploma in Civil Engineering in July 1991 with first class from the Maharaja Sayajirao University, Baroda, India. Now I request Mr. Manoj Barot sir to deliver expert session on geosynthetics in India. Now it is over to you, Manish sir.
Thank you very much, Ranjit, and thank you very much to Dr. Arup and Sujit ji for inviting me here to present the presentation on geosynthetic in India. I think you are able to see my screen.
Yeah.
Yes, sir.
Yeah, fine. So I will start my presentation. Before I start my presentation, I just want to say that this presentation, basically so far we have seen from the morning, the presentation based on the manufacturing facilities and operation and automation and operation and all these things. But my presentation is completely different. My presentation is based on the application part of the synthetic fibers. So we'll start with what is geosynthetic. I will give the functions of the geosynthetic, then applications of the geosynthetic area. In India, what are the major sectors which are using this synthetic fibers in a different product range? So first I will start with the definition of geosynthetic. The geosynthetic is the generic term, and there are a number of different products come into the geosynthetic family. A planar product, 2D or 3D manufactured from polymeric material used with soil, rock, earth, or other geotechnical engineering related material as an integral part of man-made project, structure, or a system. Screen share हो रहा है ना? Change हुआ slide?
Yeah, it's happening. Manish, you go for the full screen. This is actually on the.
Okay, fine. Just like.
It's PowerPoint's edit mode. You go to full screen.
Yeah, I will. Now?
No, now it's come. Yeah.
So geosynthetic classification. Geosynthetic is a main geosynthetic stream. There are a geotextile. Under geotextile, there is a non-woven geotextile and woven geotextile. Then under a geotextile, there is a geogrid, geomat, geonet, and geocells. This is the come under the family of geosynthetics actually. Then geosynthetic related different products are also there. That is called a geomembrane. This is a HDP liner, bituminous membrane, geoclay liners, then geoform, bioproduct, biotextiles, which is also again a non-woven and woven. So we are more here talking about the geosynthetic geotextile, non-woven geotextile, and geogrid related products. There are also geocomposite under the geosynthetic family. That is the combination of two different geosynthetic. Means drainage composite. You can see the drainage composite is the combination of geonet plus geotextile. Similarly, reinforcement composite is the combination of geogrid plus non-woven geotextile or a woven geotextile. Similarly, there are other combinations are also available as per the requirement of the project. So basically, we will start with what is geosynthetic. Geosynthetic man-made product, permeable and impermeable. There are two different kinds of geosynthetics are there. And third is a geocomposite. That already I told that combination of different geosynthetic. So permeable, it will geotextile, woven geotextile, non-woven geotextile, knitted geotextile. Then permeable, under permeable, there is a geogrid, woven, knitted, extruded, stretch, welded. These are the different geosynthetics. These geosynthetic products generally used with the help of manufactured with the help of polyester and polypropylene fiber in a different manner as short staple fiber or a multifilament or a continuous filament. Then in impermeable, there is a waterproofing sheet, HDP. That is not the topic today, but I am just showing you the different geosynthetic products. So major functions of geosynthetic in infrastructure projects and civil engineering projects are separation, filtration, drainage, reinforcement, and barrier. Separation means prevent intermixing of two different types of material, poor soil and a good soil. Like that, poor soil properties, good soils, if you have it there, then you want to separate that part. So then filtration. If there is a problem of groundwater table where you are constructing your structures, your roads or railways or bridge, then there is always requirement of the filtration. Then the non-woven geotextile will come into the picture, which will allow the waters to pass through, but it will not allow the soil particles movement. So generally by filtration and separation, you are making soft soil into a good consolidated soil. Similarly, if there is a more water heavy problem in the groundwater, then drainage. Then also a combination of net, geonet and non-woven geotextile make a drainage composite product, which will collect the water and convey to the safer space. Then to improve the tensile properties of the soil, the reinforcement can be manufactured. It is not the steel reinforcement. It is a reinforcement provided with the high tensile fiber by polyester yarn or polypropylene yarn to make the geogrid. Then barrier is an impermeable liner, and erosion control over slope also can be done with the help of geotextiles. So major applications area of geosynthetics is roads, railways, retaining walls, erosion protection work, drainage system behind the retaining walls, canal structures, reservoir and dam structures, liquid waste, then solid waste. So geotextile, a permeable geosynthetic comprise solely of textiles. A synthetic fiber are made into a flexible porous fabric by standard weaving machinery or are matted together in a random or a non-woven manner, or some geotextile are also knitted. There are at least 80 specific applications area of geotextile that have been developed. However, the fabric always performs at least one of the 5 discrete functions, that is of separation, reinforcement, filtration, drainage, or a barrier. So geotextile classification, non-woven, woven, that both product can be used to make the geocomposite also. A non-woven geotextile is a planar, essentially a random textile structure produced by a bonding, interlocking of fibers, or both accomplished by a mechanical, chemical, thermal, or solvent means and combination of therefore. These are the different manufacturing process by mechanical means, by chemical means, by thermal bonding, like that. The main bonding process are needle punching, mechanically bonding by needle with the barbed needles. Heat bonding means thermally bonded by melting the fibers from the welded parts. In relationship to the fiber length, non-woven needle punch geotextiles are divided into continuous filament on short fiber. Short fiber means the staple fiber, which is from 1 centimeter to 8 centimeter long. So again, the classification based on a process of manufacturing needle punch, heat bonded. In heat bonded, it is a continuous filament. In needle punch, it is a heat fixed with the continuous filament or a staple fiber. So these are the just microscopic views of the non-woven geotextile. This is a microscopic view that this, you can see, these are staple fibers, needle punch together. And on right side, that is the thermally bonded. So thermally bonded will give a good separation and also give the moisture barrier to the application. Then non-woven needle punch, you can see this is a microscopic view of that fibers. Then non-woven heat bonded, you can see the fibers are melted together and give the bonding. This you cannot see by the naked eyes. It is a very huge microscopic view. Then application area, that is the drainage and filtering of application. In road works you can use, in landfills you can use. So these are the different photographs of the applications. Then similarly, woven geotextile, a planar textile structure produced by interlacing or 2 or more sets of elements, such as a yarns, fibers, roving, or a filament, where the elements pass each other usually at right angle, and one set of elements are parallel to the fabric yarn. That is warp yarn and weft yarn. You already know these things. So these are the different structures of the woven geotextile: monofilament type, tape type structure, DOS type structures. So this is again the microscopic view of the woven geotextile. This will give the better tensile strength at low GSM. Instead of, in case of non-woven geotextile, it will give the more separation and filtration criteria than the tensile strength. So if you want to go for a tensile strength, you must go with the woven geotextile. And if you go for the good characteristics of separation and filtration, you must go with the non-woven geotextile. Then in some of the marine area, they both can be combined and make the reinforced geocomposite with non-woven and woven geotextile. So one will provide the advantage of the filtration separation, and woven geotextile will provide the strength criteria. So these are the knitted structure of the woven geotextile. Sorry, knitted geotextile. That is a PET multi-filament woven fabrics microscopic view. Then is the polyester woven fabric again. Then tap woven fabric, the microscopic view. Monofilament woven fabric, microscopic view. So woven geotextile is recommended where you require the more strength. That is a consolidation on a soft soil, marine works, coastal protection works to make the geotubes and geobags. Then temporary reinforced slope where you require the tensile strength into your product. Then geogrid. Geogrid is a deformed or non-deformed grid like a polymeric material formed by intersecting the ribs joint at the junctions. Types is extruded geogrid, woven geogrid, bonded. This geogrid also manufactured with the polypropylene as well as with the polyester yarn. The fundamental working mechanism is by the friction. The planar structure of geogrid is made in such a way that it will create the friction with the soil. So generally, frictional value of soil should be more than 28 to 30 degrees. There, this product will perform more to give the tensile strength to the complete structures. So these are the photographs of the geogrids, open structures, high tensile strength geogrid, monodirectional or bidirectional. Monodirectional means the strength of the geogrid is high in one direction, and in second direction it is a very low. While in bidirectional, both the strength in the both direction are the same. So there are some applications in civil engineering which will require to go only for a uniaxial or as well as for the bidirectional. So both type of geogrid are used. So extruded geogrids, they are the flat structure in polymer, usually high density polyethylene or polypropylene that are extruded and then pulled. This may be done in a one direction, mono-oriented, or in a two direction to create the biaxial geogrid. Function, they are used in a soil and road paving reinforcement. So woven geogrid, they are again a flat structure in the shape of a net made of high module synthetic fibers that may also be coated with a further protection layer. This is to synthetic material, usually PVC or other polymer. So you can see there are a same function of soil, but where you require the more stiffness, you can go for the polypropylene geogrid. And if there is a strain requirement is high, means stiffness requirement is low, then you can go for the polyester geogrid. This geogrid is less actually means price wise it is a less price compared to the PP geogrid. Then bonded geogrids, and again these are the flat structures where two or more series of strip element made of polyester coated with polythene sealed are linked at regular intervals by means of bonding. So you can see in the left side that there are the fibers inside this sealed, and the black cover is the coating. So continuous fibers are used to create the strength, and above that there is a coating of the polyethylene coating. So these are the strip type reinforcement, which is generally used for retaining structures, retaining RCC, reinforced soil wall structures. So again, polyester geogrid can be coated with the PET geogrid or with the bitumen coating or a PVC coating. So these are the fibers coated with the PVC or with the bitumen that can be used for the road applications. So again, there is a welded PET geogrid. Again, these are called the links, straps and links. Then again, these are uniaxial stretch PE geogrid. So these are the different photograph of biaxial geogrid. So these are the piled embankment, steep slopes and walls and consolidation of soft soil. These geogrids are used in generally this type of consolidation on soft soil. These products are used more on a black cotton soils, marine clays, like that projects, and to create the high strength, high steep slopes. If you have observed in the Jammu Kashmir or Uttarakhand where there are high slopes are constructed, So behind the Gabion stone fascia, there is a geogrid. So soil is reinforced with this type of polyester and PP geogrid. So principal geosynthetic product, the actual photograph, what we are manufacturing, that is a TechGrid polyester geogrid, TechGrid PP biaxial geogrid, TechGlass fiberglass geogrid, TechPave geogrid, TechGeo. Then below there is a polypropylene woven geotextile, polyester woven multifilament geotextile, then polyester geocomposite. This is a combination of woven and non-woven geotextile. Then we are also using a glass fiber and non-woven geotextile, that is a TechGlass AIC, where below there is a non-woven geotextile, and in a front way above there is a glass fiber, because glass fiber we are using for asphalt reinforcement for a bituminous road, resurfacing of runways, airport runways. Now they are using this glass fiber geogrid. Glass fiber geogrid, why we require glass fiber? Because we require a temperature more than 180 to 200 degree temperature. So that temperature can be achieved with the help of this glass fiber. Then another products like TechDrain PVD, drainage composite, PP staple fiber, geotextile bags, geotextile tubes, and polystrip strips. So geosynthetic product before using in India, as we are talking about geosynthetic in India, so we required to pass certain parameters that can be given into the MORTH specification of road and bridge works. Then we are also doing export, so we have to go for the European standards. Then we have a IRC code recommended as practice for treatment of embankment and road slide user control for geosynthetic. Then we have a codal provision of BIS also. Then available standard for geosynthetic is, you can see list MORTH 700 specification of geosynthetic, guidelines for design of flexible pavement that also mention about the geosynthetic. Then SP59 recently 2019 it is released, that guidelines for use of geosynthetic road pavement and associated works. So from last couple of years, I can say 5 to 7 years, these geosynthetic industries are booming like anything. So I will give you more picture on that. Then IRC SP42 for guidelines for road drainage with the help of geosynthetic. So there are so many documents available which can be utilized to use the product. Then certification of quality by our factory, and that shall be actually to be taken by the another manufacturer also to get the ISO certification and in-house laboratory facilities. All these things should be required by the manufacturer. Then what is the major market sector? You can see all sectors we are covering: ports and marine, power, mines and heavy industries, waste management, real estate, transportation. Transportation means roads, railways, airways, everything. Then water resources, irrigation and hydraulics. In these all market sectors, some part of geosynthetic can be utilized, and nowadays people are utilizing. So, I think someone is. Can you mute? Hello? Yeah. So application sector we are talking about the transportation. In transportation sector, in highways, airports, the major applications are ground improvement, separation and stabilization, reinforcement of a granular basis subbase, bituminous pavements and overlays, subsurface drainage, erosion control. Similarly, in railway also ground improvement, reinforcement of blanket and subballast drainage. Then soil retaining structures, soil walls, steep slope, RCC retaining walls and box culverts, gibbon retaining walls, embankments on soft soil, rockfall protection. So these are the major application area where you can use the geosynthetic in a different manner. Then why use geosynthetic? Before geosynthetic also people are constructing the roads and railways and all these things. So why we require to use the geosynthetic? So construction related carbon emissions, first is the part of that. The length of national highway is all set to increase at a fast pace. That implies huge construction works in the sector. You have also observed the number of highways and number of expressways are constructed in last couple of years, which was not the speed in the earlier government, then which has an implication of a low carbon growth, as a construction of highway generates CO2 emissions from activities like a movement of material and manpower. It is estimated that every lane kilometer of national highway constructed generates CO2 emission to the tune of 24 to 30 ton of carbon per year. The pace of highways constructed in the country has touched a record of 37 km per day in a financial year 2020-21. Government has increased year-on-year infrastructure capex by 30%. Government and has planned to build roads of worth 15 lakh crore over next 2 years. Aim is to construct a 60,000 km of road by 2025 at a speed of 40 km per day. So there is a huge scope to reduce these emissions by deploying low carbon measures in a construction of national highway. So I will brief you how I will share you 1 or 2 applications and show how we can contribute to save the CO2. So use the advanced material like a geosynthetic in road work to reduce the carbon emission. Simply by reducing the raw material like a gravels, bituminous, sands, etc. Excavating and transporting the good soil and can help increase the pavement life, which can indirectly reduce the CO2 emission from the road construction. Means if you have available of a low quality or poor quality soil at you can use the poor quality soil by using the geosynthetic material with that poor quality soil. So good resource and you are saving on the transportation cost of. Using the geotextile, then your speed of construction will be high because it is a manufactured product and easily rolled out and easily used for the road. So we'll show you the actual comparison. According to the study, cost saving of up to 10 to 25% have been achieved for the construction of a new roads using geosynthetic as compared to a road construction without geosynthetic. So I will show you status of use is during the last decade, there has been an increase in the use of geotextile for roads construction in North America. The Indian engineers are still getting acquainted with the use of geotextile. Recommendation in Indian guidelines, IRC has already published the various guidelines for the design and use of geosynthetic in the pavement, and MRTH, that is the Ministry of Road and Transport Highway, has published the specifications also in the highway manual. So I will show you base and sub-base stabilization with help of PP biaxial geogrid. This unique structure allows the geogrid to get a good grip on the agricultural interlock. So by using this geogrid, you can decrease the thickness of the layer you require to construct the road. Okay, so you can see the comparison I have shown here, that conventional road section with the sub-base, base and base course and bituminous course and DBM. So if you are going with the geogrid section, then your sub-base requirement is the same, but your base requirement is decreased by 90 mm and BC plus DBM requirement is reduced by the 10 mm. 10 mm of a bituminous layer where the asphalt is used, it is a huge cost saving because bituminous is a very costly material. So here you can see the pictorial view. One truckload of geosynthetic around 4,000 square meter comes in a one truckload, and approximately 30 truckload of GSB material can be saved with use of only one truckload of geosynthetic material. So you can say this 90 mm एकदम important slide charges is there. Hello, can you hear?
Yes, sir. Please continue.
I think there is a power gone in my residence, but I have connected with the hotspot immediately.
Yeah, yes.
Sorry. Yeah, sorry for interruption. So you can see there is a 30 truckload of GSB material or granular material can be saved by using only one truckload. So you can imagine the transportation cost, natural resource saving are a huge number of manpower of the drivers you can consider also. Then there is a huge saving in the cost and time. Similarly, comparison of a conventional solution with the innovative solution. So it is just a simple drainage part of the retaining wall where you are using 600 mm gravel layer behind the retaining wall, RCC retaining wall or a masonry. By providing drainage composite, that is a combination of a drainage and a geonet, you can see the traditional system of gravel, impermeable zone and permeable zone. And by using the tech drainage composite, again, here also you can save the 600 mm. You just imagine 600 mm. Earlier, we are talking about only 90 mm thickness of GSB material in pavement. Here again is the 600 mm you can replace with the only 5 mm thick product. So if we compare a road reinforcement with a geosynthetic to a road stabilized with a cement or a lime, again, this is a product of a lime cement stabilization. Then class 3 road reinforced with a geosynthetic is about 300 tons CO2 per kilometer lower compared to the impact of road class 3 stabilized with the cement and lime. The difference is equal to about 30% of the overall global warming impact of the construction and disposal effort of an entire road during its 30 years lifetime. This savings is actually calculated in a very detailed way by the researchers and considered with all the cost of the manufacturing cost of the geosynthetic as well as the natural resource. So everything is calculated and these conclusions came that we can contribute into 30% of the overall global warming impact. So other major geosynthetic applications in road pavement where we can save the natural resources and reduce the carbon emissions. I will not show in a detail, but I will just show you subgrade separation and stabilization, ground improvement for road embankment, drainage in pavements, base sub-stabilization, overlay stress absorption stabilization, surface erosion on road embankments. So these are the photograph of the separation and filtration. This is the below photograph is of the Vadodara Mumbai Expressway. This is a site near the Baroda where I am staying. There we have supplied around more than 10 lakh square meter of non-woven geotextile for expressway. So here the problem is the bad quality soil and above there is a good quality soil. So they have used as a separation and filtration layer. So this is the photograph of Vadodara Keem Expressway. Is a part of the Vadodara Delhi Expressway. Vadodara Mumbai Expressway, sorry. Then again the sub-base reinforcement, what I already shown you the picture. Then you can see this is the project of Amaravati, Andhra Pradesh, the pavement stabilization. There is also a problem of black cotton soil. You can see on the sides of the road, there is a black cotton soil, which is throughout the alignment, there is a black cotton soil that can be stabilized with the use of non-woven geotextile and geogrid. Then there is a subsurface drainage project in Tripura. Drainage composite for CTSB road at Agartala Udaipur Road, Tripura. Then again is a photograph of the Manipur. So what is the future of geosynthetic? So in account of increasing government investments on various infrastructure projects, such as expressways, bridges, tunnels, railways, airports, and harbors shall drive the overall geosynthetic industry has grown at a significant rate in the last 5 to 6 years. Because I am in these industries from last 15 years, and I have seen the companies that turnover of 6 to 7 crore 10 years or 15 years before, and they are increased by a multiple fold. Okay, so 10 crore company now it is a 200 crore companies. Like that is the industries are growing. I worked from last 15 years in these industries and work only for two major company. One, I work for a McAfee, which is for almost 11 years I work for there, and work for USA, France that time. Because in India that time there is a very slow pace of geosynthetic use. But after 2011-12, the speed is increased like anything. And I changed the job in TechFab India because of this Indian company and manufacturing all range of geosynthetic under one roof. So that is the thing. Continue to the slide. Government of India has already taken several initiatives through NHAI and MORTS like publishing of IRC guidelines on use of geosynthetic in road and other associated applications through a circular addressing all the executive authorities like CPWDs, state PWDs, NHI, DCL, etc. Also, railways RDSO is the key department of the railway. Without RDSO, that is railway's own design standard organization, has published the specification for formation where they can use the geosynthetic at a different level. So looking to all above points, it can be seen that very good future of geosynthetic products in coming days. Continue to the future of geosynthetic. The use of geosynthetic products in India is picking up due to its major applications in the infrastructure sector. According to the reports, the global geosynthetic market stood at a USD of 14.22 billion in 2020 and is expected to reach by 21.61 billion by 2027, growing at a CAGR of 5.6 from 20 to 27. Growing construction activities coupled with the rising application in erosion control, landfill separation and filtration shall drive geosynthetic in a demand. If we are talking about India, in India the use of geosynthetic has grown at a significant rate of 30 to 40% in the past 5 to 6 years. And the Indian geosynthetic market size seems to be around 1500 to 1800 crore in this year and increasing at a good speed of 7% to 9% annually. And I have seen in last 3 years, the number of players are also increased of manufacturing these products. As you can see, the development of infrastructure projects all over the India, it is like anything. So just to give a small brief about TechFab India, we have started in 2003 with a dream to give India a world-class geosynthetic products with indigenous manufacturing facility under one roof. At present in India, there is only one company which are manufacturing all geosynthetic product under one roof. Okay, TechFab India was founded in 2003 from a most modest beginning with the setting up of manufacturing facility of only woven geotextile in Silvassa. We have rapidly grown to become the largest manufacturer of geosynthetic in India. Today, we manufacture a wide range of geosynthetic products in our 6 factories located in Silvassa, Daman, and one is in Haridwar. So at present, we have a 500 plus employee, 6 factories, and our revenues, our only supply turnover is around 3500 millions. Our presence in India is Mumbai, Vadodara, New Delhi, Hyderabad, Guwahati, Bangalore, Kolkata. Mumbai is our corporate office. Vadodara is our technical design office, and I'm also seeing technical sales and BD from my home, work from home. And we have a presence in global. We are exporting our material to Middle East, US, Mexico, Europe, Russia, Africa, Australia, like that. Hello, yeah, if you can hear. Yeah. Yeah, the manufacturing facilities is the photograph of our manufacturing facilities, Silvassa and Daman. So these are the present manufacturing scenario. non-woven. I will not go in detail, but you can see all the geosynthetic product we are manufacturing in a different ranges. At present, in 2021, we have started a new state-of-art manufacturing facility at Haridwar. These products are not of a geosynthetic, but it is for a rockfall protection work, where we have started our factory in Haridwar, looking to the major area of our product being used for landsliding and rockfall protection work. So all our products have all our factory has an in-house testing facility as per the ISO 9000 2015 CE mark, SKSI certified, TRI certified, because we are also internationally exporting. So then all our product are also a Green Pro certified. What is Green Pro? You have seen on the symbol of Green Pro on our actually my all slides. Green Pro is a type 1 eco label which enables the end user in the building sector and manufacturing sector to choose sustainable product, materials and technologies for reducing the environment impact during the construction, operation and maintenance. Green Pro eco label is accredited by Global Eco Labeling Network through GENSIS, which is a internationally coordinated eco-labeling system. So our all products are having the Green Pro certificate. We have to meet some parameters to get this certificate. So you can see all our product is a non-woven geotextile, drain, vertical drain, PP biaxial geogrid. All these product range of ours are Green Pro certified. So conclusion, the geosynthetic solutions are technically superior and economical compared to the conventional civil engineering and infrastructure applications. Geosynthetic materials comply to the initiatives of MORTH, NHI and RDSO railway towers, minimizing the use of natural resources and reducing carbon footprint. The design methodologies and material specifications are also included in the IRC, MORTH, BIS, RDSO and standards, various SORs. Then TechFab's geosynthetic material have been certified by IITs, VITRA, CE, BIS, MDP, NAPL. These are all the certified authorities. Then TechFab India complying to the Atmanirbhar Bharat Makes in India initiative of Government of India with highest manufacturing capacity in order to supply huge quantities in short period of time as per the project requirement. ISO 9001-2015 quality certification. And we are also providing engineering and techno-commercial assistance to all our stakeholders right from the inception of the project to its completion and to maximize their project returns. We are providing all products design assistance free of cost for their products. There is a government product or a private project or a government projects. We are giving free design consultation. Then these are the few projects worldwide. You can see these are the retaining wall. Behind that, there is a geogrid. There is a block wall. Behind that, there is a geogrid. So similarly, this type of good projects, pictures, the reinforced soil wall with a tech grid geogrid in Korea. So in India also we have done, there are so many structures we have constructed. Also at present, we have more than 25 lakh square meter of wall area. We are at present designing for various expressways, highways, ROBs. So this is again a project of Bharuch, Nashik Road, Maharashtra. So thank you very much. Geosynthetic engineering for a better tomorrow. Thank you very much. Hello. Yeah. You are mute. Ranjit, you are mute.
Sorry. Thank you, sir. Thanks a lot. My sincere thanks to Mr. Manish Barot, sir, for sharing his diversified experience as a geotechnical engineer. Thank you for sparing your valuable time. We are very much confident that you have imparted valuable knowledge among all the participants. So thank you once again, Manish, sir, for sparing your valuable time.
Hope you all find it interesting and useful to your team.
Yes, sir.
As I am not aware about exact requirement of yourself, but in a short period of time, I have prepared this presentation to make
It
people
was
understand
excellent, sir.
about the
Excellent.
geosynthetic.
Yes, it was excellent, sir.
Okay, fine. Yeah.
Thank you, sir. Now
So
it's time
any
for
of your students or any of your professor required a more clarity on any product or any application or function, they can anytime contact me. I am available. Yeah. If you're for research work also you required any help from our side, you can always contact me. Yeah.
Now
Thank you very much for your
Manish,
gesture, sir.
now it is my turn to speak with you.
Yeah,
I
fine,
will
Arupji.
speak with everyone.
Yeah, Arupji.
As you rightly said, I mean, I had been a little bit silent over the period. I mean, because I was expecting Mr. Kanoi to join because he was expecting 2:55. He was supposed to join, but I was just asking the names. But so far he is not there. Anyway, so your journey started. Your company's journey started at 2003. It's the right time at a time when he took a plunge into an area where things were not happening. I'm talking about your entrepreneurship.
Okay.
So after 2003, why it didn't happen? Because of the typical political will dictated by the government of India overall, for which there was no standard. Okay. So that was the thing. Today you can boldly speak about your standards. You can boldly speak about your certifications. You can boldly speak about the range of products which is manufactured in India.
Yes.
You have rightly said when you had been in Mecca Ferry, majority of these products was on use, but imported.
Imported, yes.
Seriously imported. So it was an import substitution, but there was no encouragement to do a business with import substitution for import. Today you have. So these are the things which have happened, and it's wonderful. You have rightly said that possibly the textile people didn't find much textile related product unless they had shown the loom shade, then they find out there is some linkage. There is some
linkage. थोड़ा मेरे ऊपर से जा रहा था थोड़ा.
ऊपर से जा रहा था. But the point is, today we can get the crackless, reasonably good highways, reasonably good roadways in the state highways, reasonably good rural roads, only because of this particular product. And we have realized it over the last 20-25 years and evolved, as you rightly said, last 10 years, we have seen a growth which is CAGR more than 5.
Yes.
So I am pretty sure that all the audiences, those who are listening to it, because I am waiting for Mr. Nevatia is also in the process, and a very interesting topic on recycling. So we will not take much time. The closing up session, the conclusive session, you please all of you remain there and we will definitely discuss informally on these kind of topics. With this, I wish to switch over to Mr. Ranjit.
Thank you very much. Thank you very much, Arupji. Yeah, thank you very much. Yeah.
We'll be in touch. Certainly, we'll be in touch.
Yeah, fine. Thank you.
Ranjit, please invite Mr. Nevatia to continue.
Yes, sir. Thank you. Now it's time for the last session of the MDP program on polyester recycling in India, current perspective, by Mr. Sandeep Nevatia, General Manager Marketing, Polygenta Technologies Ltd, Nashik. It's my honor to introduce Mr. Sandeep Nevatia. Mr. Sandeep Nevatia did Bachelor of Textiles from VJTI in 1989. He has a rich industrial experience of 32 years and worked with Century Inca Limited, India, and Thai Acrylic Fiber Company Limited, Thailand. He has an experience of polyester filament yarn, nylon filament yarn, and acrylic fiber. In his 32 years of career, apart from marketing, he worked in production as well as customer support department too. He also worked with Aditya Birla Group and BK Birla Group. Mr. Nevatia is currently working as a GM marketing at Polygenta Technologies India, Polygenta Technologies Limited India, and he is responsible for sales and marketing of recycled polyester filament yarn for both overseas and domestic market. He also responsible for new application development and connecting with different brands. Now, I request Mr. Nevatia to start our expert lecture.
Thanks a lot. And first of all, thanks to Arup and Mr. Ranjit for inviting me as a speaker. And once again, to Ranjit for such a fantastic introduction. I have never thought of that I will have such a good introduction by anyone. This is the first time such good introduction is given by me. And just to add to one more point, that I am also proud today that my son has passed his mechanical engineering from Shirpur campus only in mechanical stream, and he has passed out in 2019 only. And I'm happy to inform you that now he is doing his master's in management from Technical University Munich. So his base is from the Shirpur NMIMS. So thanks a lot for all Gurujis and all teachers and professors of NMIMS. So now coming to our topic of, I will just share my screen. Give me a minute. Is it visible?
Yes, sir, it is visible. Make it full screen.
I think yesterday also I had the same problem.
No, Sandeep, you just switch to full screen.
So this is the full screen. I am in the slideshow mode only.
Slide shows full screen. Just PPT is full screen. Then it will be, you will get the.
I don't know, because yesterday also during trial the same problem was happening.
Sujit can help you out. Sujit? Yeah.
Yes, sir. Now.
Is it okay?
May I interrupt you? Sir, there is a switch at the left top of the corner.
Okay.
Beside that, we have a display setting. You are in presenter mode. Display setting. Just click on the display setting. No taskbar, sir. Display setting.
Next to that.
Next to that. Side of the show taskbar.
In the center.
Yeah, right.
No. In the upper side
Taskbar
at the center.
के बाजू में sir display setting.
This one.
Yes. No,
right
sir.
side, right
on the
side.
right. On the right side.
This is the direct mute.
Display setting right side.
Right side of your pointer.
Okay. 1 minute.
हमको कुछ और दिख रहा है क्या?
सर मुझे नहीं दिख रहा है डिस्प्ले सेटिंग.
सर वहीं पर है आपका जो पॉइंटर नहीं आपका जो पॉइंटर है शो टास्क बार पर है.
Yes.
उसके
बाजू में.
Shall I share from my side?
Yeah, sure. No problem. You can share.
Shall I share? Okay,
Yes.
So you just,
I will stop.
Yeah.
Yes. Okay. Thank you. Am I audible?
Yes, sir.
Okay. So since morning we have heard about many things, and it is the last session, so most of the students and maybe some people may be getting bored, and this topic is also a different topic. Since morning we are hearing about the manufacturing, and now this is about the recycling. So definitely this is the end of the day, so it is the recycling. So, and this is about the polyester recycling. And so next slide. Not going to in much details about the polyester figures and everything, because all of us knows what is the total global production of the fibers, what is the different percentage of cotton, polyester, nylon, acrylic, everything. So I am coming directly to the points of PET recycling. So the current production of the PET, it is around 25 lakhs metric ton, and this is the most commonly used PET resin for the plastics. This is And PET bottles are made from PET resin. And we know that use of PET bottles is inevitable in our day-to-day life. Wherever we go, wherever we see, we can find PET bottles. Even now, everybody must be having one or two PET bottles on his table, and maybe on his at home. Everybody is using the PET bottles, and it's though the government is putting some restriction of use of PET bottles, but still, as per our study, the PET bottle consumption is increasing at a rate of 13 to 14% every year in India. Overall, worldwide, it is not 14%, it is less, but in India, it is around 14% per year. But considering that maybe with the restriction of some, the growth rate will come down to 10%. So I have just figures of this PET bottles and PET resin will increase by 10%. Then from 25 metric tons today, by 25, it will be around 45 lakhs metric ton every year. So, and with this, most of the PET resin is being used for the manufacturing of the bottles, and remaining is for other applications like film sheets and other applications. The packing sheets and films is also one of the major applications of the PET resins. Next slide, please. So the bottles, different types of bottles which are being used. This is the one pictorial view, that percentage in as per the 1819 available figures, like 25% of bottles is used for packaging water and mineral water. Then fruits and drinks around 20%. Personal care, it is around 11%. For liquor, it is again 11%. Pharmaceuticals, 9%. And like this. So total, this is the approximate breakup of the different applications of the bottles, maybe even dairy and everything. So almost all bottles are recycled in India. Next. So considering that 55% of PET resin is used for the manufacturing of the PET bottles, which is most of the time is the single use, the PET bottles production will be, which is today's 15 lakhs metric ton, it will go up to 22 lakhs metric ton by 25-26. This is a huge number. And we know that PET bottles, after consumption, we just throw away the bottles. And all of us knows that PET or polyester is, somebody says it is decomposable. Is it, if I ask questions, is it decomposable? Then some answers come yes, some say no, and both are right. It is decomposable. But if yes, then after how many years? It is, as per the study conducted by some scientist or some other organization, it is taking around 800 to 1000 years, which is too long a period. Nobody will see the bottle which I have thrown today. I will not be able to see whether it has decomposed or not. So it is only as per the lab experiment. But after 1 year, it has decomposed to 0.1%. So it will be maybe after 1000 years, it will decompose 100%. But nobody is sure that it is decomposable. So what is, and we know what is happening if it is not decomposable, then how pollution it is doing to the environmental, all the benefits, all the problems what we are facing, floods and everything, choking, it is because of the non-decomposable property of the PET. So what is the alternative to the PET bottles? There are like glass bottle, copper, silver, steel. Even nowadays, the fantastic, some clay bottles are also available. So, but how easy to use this bottle. Glass bottle, it is too heavy, and the energy consumption to produce the glass bottle is much, much more, which will again impact the pollution environmental by increasing the CO2 footprint. Copper, not affordable. Steel, again, heavy. Sorry? Hello? Yeah. So, though we have options, but they are not feasible and not possible for the common person. Because, you know, earlier when there was a PET bottles was not there, we used to carry the clay, what we call it, in trains and something. We used to carry some water, mitti ka ghada, that what we call it as a, we used to carry during our journeys. But today, each and every person is having a PET bottles. So the most commonly used is this. So if we cannot use other bottles, then what is the alternative to this PET bottles? Next slide. Ranjit ji, next slide. Then what is the alternative option? Because we cannot live without this PET bottles, and if we use this, then there's so many problems. So what is the alternative option? Next. Only solution is the recycling of PET bottles, because there is we cannot use other type of bottle, and if we use PET bottles, then there is so many problems. So to live with the PET bottles and to avoid the problem, the solution is the recycling of the PET bottles. Next slide. So just going first, what is the in the PET value chain and the recycling? Who are the stakeholders? Just if we start from the resin manufacturer, which is the virgin or resin manufacturers, this is then they convert to preform. Preform and blowers is a preform is a small bottles which is by using the injection molding machine. Then by using blowing machine, we get the PET bottles, which are consumed by the brand owners like Coca-Cola, Pepsi, and Bisleri bottles, and all pharmaceuticals company, liquor companies. So these are all these companies comes under brand owners. Then we comes retailers, where we consume Bisleri water, drinks, and everything. And after that, we just discard that bottle, and that bottles goes to our waste dustbin. And then sometimes in India, it is not a very, because of the population and not a disciplined population, we just throw it away here and there. So the rack pickers collect the bottles, they give to kabadiwala of their individual mohalla or individual locals. Then this is rack pickers and kabadiwala, and from there to flake manufacturers. It is a very good supply chain. Like each and every rack pickers, they are giving to collect nearby their collectors. Those collectors are collecting the bottles, buying the bottles from the individual rack pickers, and then they are giving to the aggregators or wholesaler, and then they are giving to the distributor, and then it is coming to the flake manufacturers. So this is the complete supply chain from rack pickers to the flake manufacturers. I'm just going not in much detail of the supply chain. So after that, flake manufacturers, the bottles comes to the flake manufacturers, and there the flake manufacturers removes the cap, ring, label, and the neck of the bottle, which is not of the PET resin. This cap, rings, and are the PP or PVC, which cannot be used for the recycling of the yarns and fibers. So after production of the fibers and yarns, then it goes to the knitting and weaving factory. Then it goes to the garments, And this is the complete chain like this, from resin to the garments. So in the pictorial view, if you see used bottles, then bottle baling, then they are doing the sorting because they are removing the different color bottles, different parts which are not used and which are of not polyester. Then it goes to the flake washing machine, because like for the virgin polyester, PET and MEG is the most homogeneous raw material, and for the recycler, this PET bottles is the most heterogeneous raw material. So it has to go through the various process of washing, hot washing, and then cutting and everything. Then it is coming to the spinning and drawing, and then the staple fiber or the filament yarn. So this is the complete chain of the recycling. If I'm going fast, somebody can stop me. Though there are two different technology of recycling of the PET bottles. One is the mechanical recycling, another is the chemical recycling. Mechanical recycling is the most commonly and widely used technology of recycling, whether in India also and around the globe also. It is cost effective also, and but the disadvantage is it is mostly used for the production of fibers and some coarse denier filament yarn. Whereas in chemical recycling, which Polygenta Technologies is using, it is used for the filament yarn, it is used for the micro DPF yarn, fine denier yarns, and very few manufacturers. And in this, just very few means it is we can count on fingers about the chemical recycling manufacturers. I will just go in slightly detail of the chemical recycling and mechanical recycling. In mechanical recycling, just the flakes what we are getting, it is just through hopper, it goes to the extruder, it is just melted, and it is through the spinneret, it is extruded and making the yarn. Whereas in chemical recycling, this is a complete process. In this slide, what you are seeing, like if you see the upper half of the slide, where we use the crude, from the crude oil, we get the PT and MEG, and when we mix it, PT and MEG, it forms a ester, and then we do the polymerization of that ester, we get the polyester. And the applications of polyester, which is a virgin polyester, it goes to textile, films and packaging, and bottles. So here ends the cycle of the conventional PET manufacturing process. And the recycling starts from the bottle. For us, the end of the conventional recycling, bottle is our raw material. From the raw material, from the bottle, waste bottle, we get the flakes, and that if you see, there is a renew unit of patented technology, it is mentioned. So this is our patented technology of Polygenta Technologies Ltd, where we do the glycolysis process, then we filter the solution, and we make the ester by doing the glycolysis and depolymerization. And the ester of our process, which is, and the ester quality of the conventional process, the same quality. This is the same quality ester what we are producing and what virgin polyester manufacturers are doing. And we have checked the properties of both the ester, and it is the same. And once the ester is formed, then we are also doing the polymerization, and our yarn, what we are making, can be used for textile, films, packaging, and bottle again. And we are supplying to all. Means textile, it is our bread and butter. Our 95% of product is going to textiles. We have made the films and packaging, films also for the packaging, and of course bottles also. Still in India, bottle to bottle still not allowed for the food grade and other applications, but we have tried, and it has worked out. Only we have to increase the viscosity of our polymer, because for the bottle we need a higher viscosity. For textile it is 0.655 or 650. For bottle maybe we have to go for the 0.70. So this is in slightly detail about the chemical recycling. And our process is patented. And what in the previous slide I have said that it can be used for fine denier, micro DPF, and everything. And we are making 75 by 144, 75 by 200 deniers also using our recycling technology. So, and this is the wonder of this our patented technology. And just for your information, our technology was designed by one of the Australian scientists, and we have purchased that technology from them, and we own that technology. Next. And this is some of the environmental benefits of our process. This is not the advantages of the recycling, but the advantages of recycling of the Polygenta technology. So we reduces consumption of the crude oil, like over 2.5 million post-consumer bottles we are consuming every day in our plant. And recycling of 1 ton of PET bottle waste saves 3.8 barrels of oils. 86% of the less water consumption, 75% less energy conservation. Landfill, we know that landfill is the biggest problem, because as earlier we discussed, it is decomposable, so it is used for the landfill. So by reusing 1 ton of PET waste, we are saving landfill of 5.6 cubic meters and reduce carbon footprint. And this is the benefits. These are benefits, not just we are saying. This is the study conducted by ThinkStep Germany, a German company, ThinkStep. And this is the advantages over the virgin polyesters. Next. Like when we discuss about the alternative to PET bottles like glass or something. So if in this, I have just tried to show the energy requirement and other problems of the glass and everything. Like energy requirement for glass is 1600 degrees centigrade to produce glass bottles, whereas for the PET production requires 275. Similarly, for carrying, for packaging, PET bottles can be packed in the 3-ply boxes or even by the shrink wrapping, but for the glass bottles, it is not possible. Space saving, health safety also, all these are the disadvantages of the glass bottles. And of course, the injuries to the workers. Next slide, please. So in numbers, just this is about as per the 2018-19, the consumption of the virgin PET was around 1,000 tons per annum. So exports and IFID calculate then 870,000 tons per annum PET was consumed for bottle application, and we recycled around 85% in India. Just this is the 85% figure of India. This is one of the best in the world for the collection of the PET bottles. Only the country which is collecting post-consumer PET bottles, which is collecting more than India, is I think Germany, which is around 95%. Otherwise, India is 85%, and USA, which we used to say this is the most advanced country and everything, USA is able to collect only 25% of the bottles. So rest is not collected in USA. And if you go by the quantity, India is the biggest collector, because Germany 95%, but the consumption is less. And out of the recycling, 91% is used for the fibers and yarns, because bottles to bottles still not allowed, as I said. So straps and sheet is about 9% is the straps and sheets. Next. Ranjit, next slide. Next slide, next. So next also, next. This is not. So this is the value chain of the PET recycling. Just this is the approximate figures, like waste collectors gets around 12 to 14 rupees a kg, and kabadiwala will get 18 to 20, then aggregators 20 to 25, then baler or trader, and then the recyclers. So this is just as per our study conducted over a period of time. So this is the PET consumption in PSF and filament yarn by location wise. In India, there are so many manufacturers. Next. So these are the different products, or we can call it reincarnations of the post-consumer PET bottles. From the PET bottles, we can make the apparels, t-shirts, we can make belts, straps, we can make filament yarn, fiber, cushions, everything. All these are the, so whatever we can make from the virgin filament yarn and fiber, the same quality can be used by recycled fiber and yarns. And I am proud to inform you that our yarn is consumed by most of the top big brands. They are, just to name few brands to whom we are supplying the North Face, we are supplying to Adidas, we are supplying to Puma, we are supplying to Target, we are supplying to Bestseller, and our biggest customer is Decathlon. So all these big brands, fashion brands or sports brands are our customers, and all brands have taken their targets to change from use of virgin polyester fiber and yarns to 100% recycled. Ranjit, next slide. Hello, Ranjit, next slide, please.
Yes, sir. Is it visible?
So around 21 billion bottles are recycled every year in India. This is the figures of the India, and 1 billion t-shirts are made from recycled PET fiber. So this is the about the recycle, but this is not the end. Next slide. Next.
Yes, sir. What is next? Yeah.
So what is next? Because once we do the recycling, we have made the yarn, we have made the t-shirts. So this is this end? No. Please next. Because what we are doing till now is bottle to textile. This is the future of the recycling now. Bottle to textile now most commonly used by most of the manufacturers, and this is now, it is a set technology, and though it has many advantages like for the environmental benefits, but still to produce bottles we are still consuming the crude oil. So the future, in the opening session somebody has said that only the recycling of the bottles is not an end. So future is the recycling of the garments. So once we, like what we are doing, or any recycler, they are making yarns from the bottles. So now the future is from textile to textile, because we are throwing away the garments and then it is going to waste. So now the future is textile to textile. So once garment is made, then again this has to be reconverted into the yarn and garment. And Polygenta is one of the pioneer. Now we have already installed lab scale, a pilot plant, and we have already started doing textile to textile recycling. We have tie up with 2 brands who are ready to buy the yarn made from textile to textile. Though there is some people are saying that we have done the textile to textile, but not at a commercial level. Nobody has done, not including Polygenta. Still commercializing of textile to textile is maybe 3 to 4 years down the line. Next. Now, so textile recycling will be complete circular recycling, where discarded or used garment will be recycled to produce yarn and fresh garments, and again and again and again. So this is the recycling in India, and what we should do now, textile recycling. Bottle to textile is now it's not. So thank you for your patience hearing. Thanks a lot.
Thank you, sir, for sharing your experience and technical details and sparing your valuable time with us. We are certain that all our participants have learned a lot from you on recycling. Now, I request our beloved Associate Dean, sir, Dr. Arup Kumar Rachit, sir, for concluding session and vote of thanks.
Yeah, very good afternoon. Before I take over the opening of concluding session, there is one raised hand for Mr. Harvinder Singh. Can you, Ranjit, can you please connect with this person? What was his question or something? Mr. Harvinder Singh.
Yeah, Mr. Harvinder, please unmute yourself, Mr. Harvinder.
Yes, good afternoon, sir.
Yeah, just on your video.
Hello.
Yeah, you are audible on your video.
Put your video on. Put your video on.
From desktop only, sir.
Okay.
Hello, sir. I just wanted to know, sir has mentioned about recycling polyester. I just wanted to know from different grades of recycled polyester bottles. So, what is the criteria for selecting whether they are recycling it grade wise, or it's all through the same content?
Mr. Alvinda, we are doing the recycling of, at presently, we are doing recycling of the PET bottles, which is used for the drinking water.
Yes, fine. But again, sir, in that there are some different gradings also.
Yes, it is. There are different grading. Our technology is capable of doing the recycling of all grades, all colors, hard bottles, soft bottles, everything. But right now we are doing for the transparent water bottles only, because in India ample quantity of bottles is available, and for next 10 to 15 years there will not be any problem for the this small this kind of bottles. And just to let you know that about the quantity, our present production is just 35 metric tons a day, which we are expanding to 250 metric tons a day by next year, end of next year. So our technology for chemical recycling, yes, any grade of bottles can be consumed. For the mechanical recycling, there is just some constraint.
Okay. Thank you, sir.
Thank you. It's continuation to the same. I mean, what Mr. Harinder was asking to Sandeep, to Nevatia. Do you take colored bottles?
Yes, sir, we do, but and our technology is capable of removing colors also. And removing colors is also one of the patented process. Like, just to give a 2 minutes, I will explain you about our technology. The PET flex, what we are getting, we are doing the glycolysis using the MEG monoethylene glycol. In worldwide, the glycolysis process is not a uncommon. It's very common, glycolysis in milk. But our glycolysis is also patented because we are doing in 2 steps at a lower temperature. First is from at 100 degrees centigrade from solid to liquid form, and then we are reducing the viscosity, and the PET flex viscosity is around 0.7 or plus, because bottle grade resin is around 0.75. So we are reducing the viscosity of the solution to 0.1 or even less than that. So it is as good as the water. So it is now easily filterable. So filtration is one possible, one is the process, and the decoloration is the process. So these two are also included in our technology, because I have not gone into the detail of our technology.
No, not required.
No, it is, though it is patented, but I can share you the detail. What is the steps? I can share with you the different in a separate mail. What is the technology? So it is possible to remove the color, and we have done that also.
Cost per unit of the recycled polyester coming out of the mechanical process and the Polygenta process.
Yes.
How much it is comparable?
To be very honest, I don't have the figure of the mechanical recycling.
Okay.
And our cost is slightly high because of the scale of the production. Our production is very.
So
and we have started from scratch. This is the lab technology. And when we purchased this technology, we were not sure whether it will be to go to the commercial level or not.
Yeah. Wonderful. I mean, it's definitely a very informative and relevant to the current situation of the industry. So thank you very much, Mr. Nevatia, to be with us for this wonderful presentation in this session.
Thanks.
We will now, Ranjit, we can move on to the concluding session now, I believe.
Yes, sir.
Just in this session, I have one request, that Mr. Naveen Agarwal was especially inviting for this program today in the morning, but I think he will be able to join in this session. Mr. Agarwal is Vice President.
So I'm already here.
Sorry. Very good. Good evening.
I joined for concluding session, but sorry, sometime.
No, it's absolutely okay. Absolutely. Thank you very much to be with us. And it's our pleasure and honor that, every time this is the 6th program, and all the 6 programs have been attended by Mr. Agarwal. Whether he is on the move, whether he is in the office, whether he is sick or whether he is normal, he definitely joins. Same thanks to Mr. Gohain, who is consistently throughout the year, he has been listening. I think he is getting a lot of media coverage here in this program. Thank you, Mr. Gohain, to be with us in this concluding session as well. And Rashmi Shah, Mr. Rashmi Shah also joined. I want Mr. Biplab Chakrabarty to put your video on, to put the camera on. Biplab.
In fact, this morning, I was a bit tied up in some meeting. I would have loved to listen to all the eminent speakers, like I know Sandeep Acharya very well.
Yeah.
Biplabji, Sudipto is my, from VJTI, we know each other very well. Manish ji, and lastly, I think Sandeep Nevatia ji. I would have loved and gained a lot of knowledge, but sorry, sometime due to some business priorities. But at least I'm good that I'm attending this session to see all, listening something from Manish ji at the last, Sandeep ji at the last. But it's okay. I think next time I will ensure that I'll attend full program.
And now, Mr. Agra, don't get disheartened. I mean, the entire program will be recorded and will be available on the YouTube channel very shortly, maybe tomorrow or day after tomorrow. So please enjoy the program with all the details. So all the, except Sudipto, I believe, all the authors or the speakers are there. I'd like to thank all of you from the bottom of my heart on behalf of CTF, on behalf of NMIMS, to all the speakers, those who have really enriched the program beautifully, and they have done the best possible, information insemination in this particular session. This is what my belief is. I'd like to start from the back to the front. That will be more easier for me to recollect that what has happened. Mr. Nevatia has given the, a certain, there was a point when Polygenta used to be silent about the technology, but today he can equivocally say that, okay, no, we are chemical processes, but we can share with you, no problem. Thank you, Sandeep, that this is the courage what Polygenta has also gained, that, okay, the process what we follow cannot be copied so easily. 101% true. There are many recyclers, those who are relying on mechanical processing, and that's a great, approach from your side. Thank you very much. Regards to your seniors also in the company, Makrand also, please convey to my thanks to him as well.
Sure.
Next comes Manish ji. Yes, wonderful background. बैकग्राउंड सबके अच्छे हैं, वैसी बात नहीं है. अच्छा, इस दिस सेक्शन में हम लोग सिर्फ इंग्लिश नहीं बोलेंगे, थोड़ा सा हिंदी भी बोलते हैं, क्योंकि इनफॉर्मल हो जाए, ऐसे स्ट्रेट जैकेट नहीं. Fortunately, nobody is wearing the. Right. So Manish ji has a wonderful background. It essentially talks about geo applications of this thing. And I mean, whenever I was thinking about your listening to your presentation, I was thinking.
Brilliant, sir.
Textile person talking about the efficacy of a or air jet loop or some other things. See, unless you are a civil engineer, you will not be able to speak strongly about what is geotechnical approaches, geosynthetics or geotextiles, right?
Thank you.
So that was something what is also nicely presented. I'm sure that the audience, 90, 100 people on an average. Monday morning, it was around 130 participants. This time about 100. So I'm sure that the audience have got a lot of ideas about the geosynthetic application, which they can develop on their own. And if there is a request comes into our coordinators, certainly we will try to organize such program once again, which is specifically on the topic of geosynthetics or geotextiles.
Fine. Thank you very much, sir.
Getting back to Industry 4.0 from Sudipto Mandal. We are now listening, I mean, Industry 3.0 से तो मुझे पता है कि शुरू हुआ था, मतलब जानकारी कि हाँ 2.0, 3.0, 4.0 हो रहा है. क्यों नवीन जी? Is something like that. So it's wonderful that automation, virtual reality, artificial intelligence, all these kind of things are actually the technology of tomorrow. It is linking the productivity, which is also extremely important for Indian scenario or Indian context. So we have machines, but productivity is in question. Why it is for? So those things will be definitely addressed more effectively here. Biplab ji, namaskar once again. I'm really
very good afternoon, sir.
Anything more? First thing, it's a wonderful classroom you created when you had been talking about the tyre cord. Fantastic presentation, Biplab. It appears to be, I am recollecting those days when in my college days when our teachers used to talk about the tyre cord, how it is being constructed. That cycle tyre was only our funda, and then it has come the aircraft tires also. Wonderful presentation.
Thank you.
And right time, the right clarification of a terminology. I appreciate you. Thank you so much. And we have already gained a lot of information about what is there inside the tyre. I remember Professor Gupta, V.V. Gupta's lecture in IIT Delhi, who says that 138 degrees Celsius temperature reaching if a truck loaded with 20 tons or 30 tons of material and running at the 46 degrees Celsius outside in the Rajasthan roads, the inside tyre temperature reaches anything around 140 degrees Celsius. So your 150 touches the same figure, and I'm sure that if the studies really show this, it establishes the accuracy of the study also. I mean, how you can reach the temperature, you can read the temperature of the tyre inside. Thank you very much once again to be with us and sharing wonderful information on a specific application of the synthetic fibers. And now the first one, bulk continuous filament. Where is Acharya sir? Yes. Now you have a different background, Sandeep. I couldn't make out. Put your microphone on. Put your microphone on. Microphone.
Yeah. Now can you hear? Yeah.
I can hear you. Everybody can hear you and see you also.
Yes.
First thing is that hats off. I mean, I should definitely appreciate and preach with the students of all the time possibly. To remain an expert of a single thing. The person next to you on the screen, Biplab ji, is also a tyre cord person over the last 20 years.
Yeah.
You also remain a BCA person, possibly over the nearly 12, 15 or 20 years. That makes sense. It's a message to many of us. You look at the special inviting Mr. Naveen Agarwal, machinery, sales, and related activities, entire career.
Yeah.
So this is extremely important. So if you become an expertise of a certain thing, do practice it by the core of your heart so that you become a perfectionist in that. Okay.
Yeah.
Thanks to Gohin also, who is there for 20 years in the media publicity professionally. Fantastic. So these are the things I would like to share. Nothing to say about the bulk continuous filament here. It's a relatively load, but definitely your expertise. India also, we have sufficient establishment of BCF. If Sudipto was there, I could have also asked him that what are the new setups coming up in BCF.
Yeah, there are a few setups coming up. Yeah.
If you can comment upon it, you are welcome.
Yeah, there one is Aquafil is coming, Italian company who also pioneer in recycled nylon Econil BCF. They are coming to India, and I heard of 2 more projects, big projects coming in north or central part of India. I'm not sure exactly, but the news seems to be authentic. Yeah. Possibly Oerlikon person can tell it in a, I mean, more authentic, yeah.
More authentically. But anyway,
some of the news doesn't come up so quickly. Many things are confidential. But I think the future maybe in BCF slowly, as it is picking up. Like Eva and Bikelon already have set up the big units. Like Eva already have, I think, 16 lines, which is a big thing. Once upon a time in entire India, there were not 16 or 15 lines. That was the scenario. So the things are changing, and hopefully the things are changing for better, I would say. Because see, everywhere the operating costs are high. And strategically in polyester, we are next to China. So at least in polyester BCF, I would see a good future. I don't want to comment right now on PP because Turkey is excellent in that, Turkey, and we cannot compete maybe with respect to overall. But polyamide and maybe polyester, we have got an RPT, we have got a great scope in BCF in coming years. That's what I feel. I may be wrong, but this is what my expectation is.
Very nice. Thank you for your comments and observation. I would like to move on to Naveen. Now, one second. Before that, let me listen to Gohin. Please try to give your comments in the concluding session, please.
Yeah, thank you so much. I could not attend most of the session. Only the last I have attended. But what I understand and what I have said, mentioned in the morning, that 4 things that are going to happen. Many of the speakers have validated that fact that India is going to grow. India has cost advantage. India has enough manpower, and all our entrepreneurs have willingness, and Indian government is promoting Make in India. And with this PLI scheme, especially for man-made and synthetic fibers, I guess we'll have quite a few number of large organizations in this area.
Very true.
Just,
yeah.
Thank you.
Thank you. Thank you once again. Naveen is video off. Let's come back to him by the time he comes on once again. Mr. Shah, who is here. Mr. Shah, are you listening? Please put your microphone on. Rashmi ji, namaskar. माइक्रोफोन ऑन करिए और आपको अगर अपने सेकंड हाफ हेलो हाँ
yes
second
first of all congratulations to Arup ji. The students are becoming a future leader. Let me tell you, no institute is doing this work, though I am from VJTI, but you are doing excellent work. That is the thing I can say now. I missed because we had a meeting in the earlier session. I joined this, and Mr. Manish Barot, excellent presentation. You don't need to be a textile graduate to talk on geosynthetics.
Thank you very much, sir. Thank you very much.
मजा आ गया.
Thank you, thank you,
Thank you, thank you, Arun ji, once again.
Thank you. Okay. Naveen has come with the video. Naveen, now your time to comment upon Mr. Agarwal. Microphone. Naveen, microphone off.
Sir, please. Yeah. Now it's audible. Yeah. So first of all, I think we are the cotton dominating country, because we cultivate cotton and we try to spin that into yarn, and the yarn got converted into fabric, and then we did. But now somehow we missed from decades and decades to venture too much into synthetic. And now the time came where the government initiative, particularly also their initiative to uplift the synthetic industry, particularly with the PLI scheme, or whatever scheme, the large scale scheme to come, wherein the consumption and the utility of synthetic, even the production will increase. And irrespective of how much cotton we cultivate, but the parallel, the world in the world map, we are quite behind with respect to synthetics. And this will take us to the next level of making export and growing our Indian textile industry. Also, the technical textile routes are basically attached to the synthetic, and there again it requires that we should not depend on the yarn to be imported. And if we produce those yarn, definitely we can produce the technical textile articles in India, and that will prosper India in coming time. So at least I can say next 5 years till 2025, we are into very strong position as of now. And these 3-4 years will make us further stronger in the Indian textile industry on the world map also. So I think we see quite good perspective for India also developing with the synthetic. Of course, Surat, Silvassa, these belts are quite prominent, including some Panipat and Amritsar area. These belts are quite prominent for synthetic, but the other area should come, like now Kolkata is coming up with petrochemical industry, putting up some yarn manufacturing project. Indorama aiming to expand the capacities. So there won't be any monopoly of one player in the coming time. And this will grow the Indian textile industry to the drastically and to the good phase. So maybe all the speaker must have covered all good things in their presentation. Of course, since I have not heard, I cannot comment. But I know all their capabilities. Particularly, I know Sandeep Mahajanji, Sandeep Acharya ji, or Sudipto. He must have given. They are the king now on the synthetic line supplier. And all other I heard, particularly Sandeep ji, Nevatia ji, and Manish ji. So I think we are also seeing as a machinery people that how the synthetic machines are more in demand compared to, of course, cotton spinning demand is also going on, but parallel synthetic is also increasing. So wishing all the best for all of us and the industry to grow further, and to the student to get better job. If more industries coming, variety of industries coming, our upcoming students will get better job in the industry, and we too as a technocrat can find a better option. Thank you.
Very nice. Thank you for your observations and consolidation of the information. Very nicely. Yeah. Thank you. Mr. Chakrabarty and all other speakers, everybody, if you have to express something about the program, the composition of the program for today, or the future expectations and any type of your suggestions for improvising the program. Mr. Chakrabarty, please.
I have something to say. Sorry.
No problem.
It's okay. You carry on.
Okay. I have one thing to say, mention here. Everything, I mean, we see a good scope, expansion going on, but I see a big gray area, which is specialties. And I always, actually, whenever I get a chance, I talk on this. because I'm associated more of specialties and not into the commodities. This is the area where China is far ahead of us, far ahead of us. And since now the world is looking for the alternative, this is the chance where we should move into the specialty products or like functional products or bicomponent and all. Bicomponent, for example, bicomponent, hardly any lines in India except Reliance and AYM, because probably we do not have the downstream processing ready to cater to this kind of fibers or yarns. So this is the biggest gray area where the, I think, wake up call should be there in the industry. More of the people looking for an easier way to sell or commodities where they do not require a great amount of efforts to sell this. Like example of AYM, they came up without any background in BCF, and in 5 years, let me tell you, from New Zealand to Canada, they are supplying to each and every best carpet manufacturer, specialty. And even when the COVID was going on, average 120 containers were exported per month, 100 to 120. So this shows that everything is possible. But if you see now, there are hardly any companies like this. Forget about BCA, but even in the specialties, normal specialty polyester fibers or any other thing, a lot of scope to acquire this European monopoly, Chinese monopoly, and we should start in. But more of a people, I would say, were investors very happy to go more into commodities, but not very keen into go for a specialties where high amount of efforts are required with respect to technology as well as marketing and a development, of course. And you require a really right and good people to handle this kind of product portfolio. So this is just I wanted to mention.
Yes, correct.
Yeah, fine.
Very correct. Yeah. Chakrabarty sir.
Dr. Roop, I'll just pick something on this program per se. It was very nicely managed and beautifully sequenced, no doubt about it. Only one thing which I don't know whether there is any solution to this or not. Sometimes we are facing some network issues. So in that case, what was happening that we are losing attention and the speaker's message or communication was interrupted. So if anything can be done on this as a special case, probably at the day of the event, if we can have extra bandwidth or something, that will be very essential, very useful, so that we can be, the participants would be 100%. Otherwise, a lot of distraction was happening some of the times.
Correct. Absolutely correct. I have one question from your presentation, because at certain point of time you mentioned rayon tire cord for racing car. I am still remembering what was the justification. I mean, can you please expand about it?
Yeah. See, in rayon, rayon is having the maximum durability, and heritage,ally it has happened that any formula car, when they are making, still they are banging on rayon, because the durability is maximum in case of rayon. Rayon tire cord is become a little bit of, I mean to say, it's not very common in these days. Many of, and 80 to 90% conversion has already taken place in case with nylon 6 and polyester. But especially for the high speed tires, where the speed is a factor, but life is not a factor, because they go for only one run or two runs, they take use of rayon there.
Oh, I see. Okay. Good. Yes. Anybody want to express their views, points?
Just add into the bicomponent fibers. It is not only a filament, also people can go for bicomponent fibers. In 2008, we have developed certain fabrics which has 4-way stretch, because lifestyle needs a lot of comfort nowadays. So bicomponent fibers can give a lot of good stretch, which will have very less amount of growth when consumers use it. So people are nowadays very comfortable with spandex, lycra, and all those things. But we have seen that with bicomponent fibers in the fabric, you get 4-way stretch, and that gives ultimate comfort. And the fabric doesn't shape like use spandex. Just a comment to Mr. Sandeep.
Yeah, especially PET, PBT side by side. Excellent. Yes. 60-40 we have done when I was in Reliance. We produced that first in 2002, I think. That was the first with the Hills technology. and that was amazing fabric we could produce in Surat. But see, again, over the period we had to change the products. But this side by side PET PBT, one of the best, having excellent stretch and high shrinkage and fill properties, which you cannot achieve by any other modification unless you go for some softeners and all these things you do. But without any modification, you cannot achieve such kind of thing. That's how.
Very correct.
Yeah.
So with this, can we conclude the session for today? Can we come down to the end of the session? Mr. Ranjit? Permitted? Okay. So at the end of the day, thank you once again, all the participants, all the speakers, and all my colleagues, those who have maintained their consistent effort to make the program successful. Thank you once again. Thanks to all of you. And please write to us. Please be in touch with us so that we can improvise with the content or the procedure.
Thank you.
Biplab network issue is once again thanks to the Indian process. In fact, we used to do it on Saturdays. Okay, at certain point of time, at least 2-3 programs we tried to continue on Saturday, but I found that from the location where we are situated, there the power shutdown comes for 4 hours on Saturdays only, not on Sundays. So Saturdays. So therefore, we had to shift it to gradually, Saturday to Thursday, Thursday to Wednesday. So it's the best. Now we have chosen the last Wednesday of the month for this kind of programs. And all of you will be in our mailing list. So forthcoming programs and our past programs, all these things will be intimated to you. Those who are interested, you can share with them. And these are the few words from my side. And
thank you very much.
Goodbye for the day.
Thank you, sir.
Thank you. Bye.
Thank you. Bye.
Thank you, sir. Thank you all.
Thank you, sir. Thank you.
Thanks all. Thanks all, and bye. Thank you.
Good day.
Take care.
Bye. All. Thanks for inviting me.
Thank you, sir.
Thank you for coming. Thank you.
You are always there here. Okay, so you have to
Thank you, sir.
Mark your date for every last Wednesday of the month, preferably.
Sure. Thank you very much.
Bye-bye, sir. Thank you. Thank you, Glenn, sir.
Thank you. Thank you.
Thank
Bye.
you, sir. Bye-bye. Bye-bye, Biplab, sir. Thanks a lot.